Hi, hi, hi. Good morning, everyone. Thank you so much for being here, bright and early at Tulane. Yeah. My name is Liz Maxwell. I'm the executive producer of New Orleans Entrepreneur Week and year-round staff at the Idea Village. It's an honor to welcome you all here this morning. This is actually day 4 of New Orleans Entrepreneur Week. It is Thursday in the week. It is also the 9th annual Halliburton Labs Pitch Day, which is what we're here for, and the first ever Third Coast Venture Summit. So the way we've designed the week this year is a hybrid format of all of these partners coming together to collaborate for the full week, multiple days. I just wanted to say a quick welcome and hello from us. Across the way here, if you're attending Third Coast Venture Summit, in this next building over, we'll also be having programming and pitches all day long. If you're here for New Orleans Entrepreneur Week, you can find more information at this table and at noew.org with the full schedule of the week. We're also collaborating with the Book Festival here at Tulane University for tonight. Thursday is the kickoff keynote, and then Friday and Saturday here the rest of the week. So it's an action-packed schedule. If you're live online with us, this is the only event being fully live streamed, I believe. So lucky for you, you get the highlights, and you're just going to have to come to New Orleans next year and catch the rest. I will turn it over to the Halliburton Labs team in just a moment. I just wanted to say it's been a real honor for the last several years now to collaborate with Halliburton Labs on hosting mini summits, and then this is the first big event we've done together in this space, but to do more on promoting clean energy technology, the future of climate tech innovation, and so it's just wonderful to partner and gather everyone together to have these really critical conversations. So again, thank you for being here, and I'm going to turn it over to the team.
I think we've got a lot of the technologies that need to exist today, but certainly there's going to be new things that we haven't even thought of.
Being an entrepreneur is difficult. They are taking the risk. They are trying to do something very disruptive.
At the end of the day, it breaks down into parts that are led by small groups of people with an idea that is literally considered to be crazy.
If you are an entrepreneur and thinking about Halliburton Labs, it has a great team, but it also draws from the rest of the company in a way which is really special.
The infrastructure lets us focus on our process, not on building cooling towers and nitrogen pipelines.
The thing I noticed immediately about Halliburton Labs was a very supportive environment, borne out by the fact that every time I speak with somebody at Halliburton, they say to me, "What can we do for you next?"
I need someone like Halliburton's network to help me with all these aspects of technology building, scaling up, networking, finding partners.
So you have to have a team that is rowing in the same direction as you, believes in your vision, and is there to stick by you.
Halliburton Lab is one of the very few which is actually willing to share the knowledge, take advantage of that.
All right, good morning. It is an absolute privilege to be here with you. I'm Scott Gale, serve as Executive Director over at Halliburton Labs. Really a privilege to be here with New Orleans Entrepreneur Week, Third Coast Venture Summit. Welcome to everyone here who's gotten here this morning. We've got a live broadcast as well. My role here is to give you a quick few comments on orientation and then introduce this fantastic keynote discussion that we're going to have. So here in the room and online, we're going to hear a series of pitches and some Q&A. The audience has the opportunity to participate in Q&A. So for here in the audience, there will be a QR code. Submit your question. On the online platform, a little bit of a different experience. You have Q&A, there's also a chat. We also have a virtual booth that you can access while taking in the broadcast so you can learn a bit more about the companies that'll be presenting along the way. Don't hesitate. If there's any questions that you have, track down someone in a Halliburton Labs t-shirt and we'll help get you oriented. All right, so let's get kicked off. It really is my privilege to introduce this keynote discussion that we're going to have with Walter Isaacson, who is the professor of American history and values here at Tulane. A few comments about Walter. He's been on the advisory board of Halliburton Labs from the beginning and has been an absolute supporter and helper along the way. It's been really fantastic. He served as the chief executive officer of the Aspen Institute, where he's now a distinguished fellow. He also held positions as the chairman of CNN and the editor of Time magazine, and most recently released a fantastic book on Elon Musk, among many others. And so excited to have Walter here leading a conversation with Andy Lubershane, who we're excited to have here. Thank you, Andy. Andy is a partner at Energy Impact Partners and head of research, has over a decade of investing experience in the kinds of things that we're going to hear from startups and technologies today, and so excited to have Andy here and to dive into his perspective. So welcome Andy and Walter to the stage with me, please.
Well, thank you for coming. Thank you for coming very much. Appreciate it. And you've been in the forefront of trying to find the technologies that will help us with clean energy, help us with climate. First, I'm a bit of a biographer. Tell me your path to get here.
I'm a little young for having a biography of any means, but, oh, thank you. Yeah, so I started my career in energy at CERA. I imagine folks in the room are familiar with that energy market research firm, actually as a wind energy market analyst. So wind is sort of the beginning of my love affair with renewables. And then over time was doing more work on renewables, emerging technology at CERA. I heard about this fund that was getting off the ground in 2016 called Energy Impact Partners, and was put in touch with them by a friendly contact. They were looking for someone to lead market research, which was a little unusual for a small fund at the time. And the reason for that is because Energy Impact Partners was really founded by a number of corporate strategic limited partners who wanted to invest collaboratively in solutions that would benefit the industry overall. In this case, it was really founded by a bunch of utility companies, electric and gas utilities, who wanted to form a consortium to collaborate on investments rather than doing it individually in-house. And so they wanted someone at Energy Impact Partners who could work with those corporates, identify subject matter experts within those corporate organizations, get to know them, learn from them, and at the same time share information back with our corporate partners. It's really, for them, a big part of the reason they invest in our fund at Energy Impact Partners is for information, for intelligence, to have more eyes and ears on the ground, helping them navigate this emerging tech ecosystem. So they wanted someone who had experience doing that, and who knew energy markets, and I was lucky enough to be that person.
And you said you started in your head with wind, but let's go through the decarbonization. If we're going to decarbonize and have sustainable energy, start with wind. What are the upsides? Where do you see it going? What are the costs now?
Yeah, it's interesting. I think when people, there is a growing consensus in, I would say, the broad outline of decarbonization, very, very broad. When anyone tells you they have a three-part plan to do something, you should beware. But in this case,
well, you have a three-part plan.
This is the three-part plan.
Yeah, I've read it. I'm wary.
Yes, and I will say also, I should preface this by, anything in the scheme of the next 30, 40, 50 years of decarbonizing the entire economy is hard. It's just a spectrum from hard to nearly impossible. We have no clue how we're going to do it. And so this three-part plan runs across that spectrum. The first part of the plan is decarbonize electric power supply. And that's where we do have some pretty strong building blocks today. Wind power, solar power, I'll go ahead and say nuclear power, which we actually have had since the 60s. We have the pieces we need to mostly decarbonize power supply. It's not easy, it's on the just hard part of the spectrum. If you believe that, then step two is use those clean electrons as much as is economically and practically feasible to decarbonize things that are not currently electrified, right? Most of energy consumption today, as you all know, 80% of end-use energy is not electric. It's burning fossil fuels mostly directly in an engine or a boiler, an industrial facility, or in a vehicle. Some of that can be electrified cost-effectively. And then step three is basically, for the stuff you can't cost-effectively electrify, you have to figure out another solution. And that's going to be some form of clean molecular solution, most likely.
I mean, I'm sorry, clean molecular meaning?
Meaning not electrons.
Yeah.
It may be a molecule that is produced using clean electrons, electrofuels, clean hydrogen,
Hydrogen being the most obvious, or?
Hydrogen being the building block molecule for a lot of those clean molecules that we're talking about, yes.
And how would that work?
So, I mean, there's a bunch of different ways of producing clean hydrogen, as everyone knows. You can take methane, CH4, you can take the carbon off of it, and then you've got 2 hydrogen molecules. There's a hydrogen color wheel I know everyone's familiar with. That's blue hydrogen, right? You bury the carbon somehow. You can use electrolysis. You can produce it with clean energy or clean electricity to get clean hydrogen. If you have cheap enough clean electricity, it has to be really cheap. That might be cost effective in some places. And there's a couple other kind of niche options out there, some of which could be fairly big niches, but the one that is the big surprise that I was talking with some folks last night about that's really just starting to emerge on the scene is this concept of geologic hydrogen. So, you know, for a century plus, we've been drilling for oil and gas. It turns out that there is some hydrogen just sitting underground, potentially for us to tap into. We don't know how much today. It could be practically nothing. It could be a curiosity. It could be an enormous global resource. That's what we're.
And you tap into it. I mean, it's in Oman, some other places now. Would it be, say, in Louisiana, Texas?
I don't know about Louisiana, Texas, but we have a portfolio company at EIP called Coloma that is drilling for it as we speak in the United States.
And what would be the business model? Suppose you get hydrogen.
Yeah, that is a bit of a challenge with hydrogen. Hydrogen, pardon my French, someone who's worked with it a lot told me it's a pain in the ass molecule. That's the best way to think about hydrogen. It's light, it wants to escape from everything, it corrodes metal, it's not easy to work with. And so you have to figure out what you're going to do with that hydrogen. If you can produce it cheaply enough, geologic would probably be the cheapest way to do it, then you can stick it in a pipeline. Not the exact same pipeline as an oil or gas pipeline, but we have hydrogen pipelines today here in the Gulf. And you can deliver it to an industrial facility. Probably the first thing we're going to do with hydrogen as we produce it in any kind of way in a clean manner is we're going to use it as hydrogen, right? We have a huge hydrogen market today. We make ammonia, we make methanol, we make other petrochemicals. So substituting that non-clean hydrogen for clean is step one.
What are you investing in?
So Energy Impact Partners, we invest across the spectrum. We consider ourselves omnivores when it comes to clean tech. So each of those 3 steps I mentioned, I'll tell you that there are certain people in the climate policy world and the climate tech and activism world who think that, by the way, steps 1 and 2 are all you need, just, you know, decarbonize power and then who's heard the mantra electrify everything out there? Yeah. So we do not believe we're going to electrify everything. We think we can electrify a lot of things. There's a surprising number of things if you start looking for opportunities to electrify that you can electrify. But we look across the spectrum, including carbon capture and sequestration, clean molecules. We're climate hawks, but we're climate pragmatists. Anything that gets us to net zero affordably, safely, reliably, we will invest in. And I should emphasize the safely, reliably, affordably part, because part of our DNA at EIP is because we are initially backed by this consortium of electric and gas utilities, you know, their job for a century, their mantra is safe, affordable, reliable. They operate critical infrastructure at high voltages that can kill people 24/7. We all depend on it every moment of the day. We cannot compromise any of those things. The hardest part is going to be the affordability part, right? Which, frankly, like, is the big challenge of decarbonization. And that's why we're always looking for solutions that can meet the lowest possible cost benchmarks out there.
So go back to your 3-part plan. What about the grid? What other parts of the plan are necessary?
So, you know, the first part of the plan, decarbonize power supply. Power supply is a tricky beast because there's really 3 layers to the grid. There's the generation of power. That's what you can decarbonize partially with wind power, solar power, nuclear power, natural gas with carbon capture and sequestration. There's actually a bunch of pathways to decarbonizing power supply on the generation scale, which is why it's at the just hard end of the spectrum, not the nearly impossible. We have no idea how to do it end of the spectrum. But then you have to get that electricity to the place where it needs to be consumed. We have the grid today. The grid is wonderful. It's an enormous, actually international resource which crosses our neighboring borders. The problem is it's getting harder and harder to make the grid bigger. Right. When you build the grid the first time around, everyone is thrilled to have it, right? Like we go from not electrified to electrified. People are welcoming of transmission lines, maybe not exactly in their backyard, but nearby. During that first wave of rural electrification, think back in the 20s to the 50s. Today, people say I already have power. Why do I need another transmission line in my backyard? And have you heard the term banana or banana?
No.
Build. I'm in a mango, but it's like build nothing anywhere at any time, basically.
Yeah.
I completely ruined that acronym, by the way. But it's the next phase of the NIMBY phenomenon. And frankly, that combined with, I'll go ahead and say, oppressive regulations at this point for building large infrastructure, at least in this country, has made it very difficult to expand the grid at the pace we are going to need. And that's actually one of the reasons, frankly, that we're going to need more than just pure electrification solutions. If we could build the grid as fast as we needed to, you could electrify a lot more. Right now, we're already entering this period where electric utilities are having a hard time adding new capacity. They're having to turn away customers now, big data centers, big factories saying like, we can't get you power in the time that you need. It's a big challenge.
I'm going to do a small Elon Musk break here because he's involved, as you know, with decentralized grids. In other words, even in your own house, you'll have a power wall, and in your neighborhood, you'll have power wall bricks, lithium ion, huge batteries, solar connected, so it can help take things off the grid. But part of the reason I'm doing the break is I've been following, as you know, Starship, which is the largest rocket ever made, and it was successfully launched about 8 minutes ago, and it just reached orbital velocity, which is that rocket he's putting up. So I wanted you to talk, as just my pivot to mention that, but also to talk about a decentralized grid in which people in some ways can get off the mega grid.
Yeah, there's been this vision, I would say, among some in the industry, and again, I'd say more in the climate activist movement for a while, about sort of going completely off grid, cutting the cord. We'll do everything with distributed solar and batteries. I think that is a complete myth for the vast majority of people and businesses. I mean, if we're really talking about delivering all the energy we need in the form of electricity, or a lot more energy in the form of electricity, there's simply no way you can do it with rooftop solar. There's not enough space to put solar panels, even if they get a lot more efficient. And so what I envision, what I think we are starting to hit an inflection point for, is more of what you'd think of as sort of a hybrid grid, where you have the macro grid will still be critical. That's going to be the biggest delivery system for affordable, clean electrons. But we will see more and more distributed generation, distributed storage, which produce energy year-round, but are also able to make the grid more resilient during periods when there is stress. So during periods of peak power demand, they can provide power. During outages, they can island an individual consumer, or maybe even a whole neighborhood, or a industrial facility.
During a nice hurricane in Houston.
Yeah. I hear that occasionally would be valuable in this region. So I think we're going to see more of that. And by the way, it's kind of fun if you look at Google Trends, which you can search for any term and see over time how people are searching for it. Every time there's a hurricane, if you look at the Google Trends for batteries, for backup power, it goes through the roof.
Yeah.
And those companies have a good sales quarter.
So tell me what other things further down the line, after you've done the generation, the grid, that need to be done and you're investing in.
So, I mentioned step 2 is electrify not everything, but a bunch of stuff. This is an area I've become encouraged in at EIP. It turns out the more you look for electrification opportunities, the more you find. And really across all different sectors of the economy. So most people think of electrification today, they think of electric vehicles, and that certainly is the headline. And it's incremental progress, but I think we're probably now hovering right around 10% of new passenger vehicle sales in North America, which is starting to move in a more electric direction. I don't think electricity will take over all classes of vehicle, but in passenger vehicles, I think it's very promising. But it's way more than vehicles. We have an investment in a company called Moxion. They make an electric battery-powered replacement for a portable diesel generator. You can think of this as kind of the low-hanging fruit, maybe the lowest hanging fruit of electrification. Everyone hates portable diesel generators. If you're at a construction site, at an event, they're loud, they're noisy, high local pollution, of all types. They're expensive to operate. So this company, Moxion, rolls up a fully charged battery in the morning at your site. You use it throughout the day to run your tools or your event stuff. And then they pick it up in the evening, they bring it to a warehouse where they charge it overnight. They can charge it somewhat flexibly in accordance with the demands of the grid, and they drop it off in the morning fully charged. And they can do this at a lower price than you would pay for renting a diesel generator and paying for fuel. So that's like one example of electrification I'd never thought of until we met the company. And then industrial electrification is another big one. So one of our portfolio companies is pitching in a bit, AtmosZero. They have an industrial scale heat pump for producing sort of low industrial temperature heat, which is still very hot, by the way. There's other approaches to electrifying industrial heat. Another company called Rondo, it's a thermal storage company in our portfolio. There's a bunch of really promising ways of even electrifying materials production, things that people didn't think previously you could electrify, like cement. So again, I don't think there's going to be a one-size-fits-all solution for any sector, but electrification is one area we have invested in, and I think is something people shouldn't count out in even the tougher to decarbonize, tougher to electrify areas.
I see Mike from United Airlines in the back somewhere, but we'll talk to him later today. Do you ever see aviation being able to be electrified?
No. I'm sorry, Mike, if you have investments in that space. I think maybe very small aircraft, but nothing that matters in terms of aviation emissions. And by the way, that's not just because of the battery and the plane. That's because of the fueling, the need to fuel at an airport. If you were, I did some analysis. If you were to just take like a sort of a mid-sized airport, I grew up around Boston, so take Boston Logan, and you were to electrify even just 100 miles of flight range for all the planes leaving Boston Logan every day, you would, I think, more than 10x the power needs at Logan. And so you're turning Logan into like another small city from the standpoint of electricity demand. Try getting the power lines through Boston that you need to do that. It's just, I don't foresee that being possible in the time frame that we need to. So aviation is one area I am fully on board with the clean molecules thesis, biofuels, electrofuels, et cetera.
We're at pitch day here for the Halliburton Labs, and you've been involved with this for a whole lot. You've heard pitches, you've probably even done a few. Tell me what you're looking for when some entrepreneur gives you a pitch. What are the first questions you're going to ask, and what about the valley of deaths you're going to warn them about? Yeah, I mean, I think something we focus on a lot at EIP, just have learned over time is, especially for early stage companies, the team is like by far the most important. There's team, there's technology, there's market are kind of three big things you think about when you're looking at a company to potentially invest. And I think most people first are attracted to technology, right? Because it's fun, it's exciting. You could theoretically generate intellectual property and have a technology-based moat. Actually, technology-based moats are surprisingly rare, right? Team moats are actually the thing that wins championships. Because if you're starting a company from scratch, the first thing you're doing is hiring a bunch of people, right? When we give a company money, when we invest in a company, usually they're taking that, and the first thing they do is they go hire 10 more people, which means you need to be a good hirer. That's like one of the core skill sets of a founder of a company. You need to be a good inspirer, someone who's able to create a vision, tell the story of your company, go raise potentially hundreds of millions of dollars more. So, every time we think we have indexed too much on management team, we think we should index more on management team. Like we learn the lesson again. So
I guess the lesson for founders is think mostly about who your first 5 to 10 hires will be. Like, you should know that before you start raising money. And then in terms of approaching these valleys of death, right? I often think about 2 valleys of death. There's the technical valley of death. If you're starting a real hard tech company, like you need to prove the technology works, make sure the science is rational, and then you need to demonstrate some minimum viable prototype or demonstration scale product. And I actually am less worried about that so-called valley of death today. Way less worried than I was 10 years ago. There's a lot more capital in the market, whether it's government grants, ARPA-E, which is a phenomenal program. Even today in a depressed venture capital market, seed stage companies are still seeing a lot of activity in the climate space. It's the commercial valley of death that's the harder one. So you've built a demonstration scale project, and it works, and now you need to scale it up 10x, and you need to raise not tens of millions of dollars, but hundreds of millions of dollars to build a manufacturing plant or to just build the first of a kind project, which is never going to be the cheapest version of the project. That capital today is a major gap in the market. And again, it's only the most stellar companies who have an incredible team with project development experience, financing experience, execution experience that are going to make it through that.
Yeah, we're here with Halliburton Labs, which was formed, of course, by Jeff Miller and Halliburton, somewhat in the model of Bell Labs being formed by the Bell System, Xerox PARC being done. And it's the role of incumbent companies to say, how do we think different? How do we sometimes do things that might hurt our existing lines of business? Steve Jobs was always ready to say, I'll cannibalize the iPod in order to get the iPhone. What do you think the role of incumbent companies are in getting us to a clean energy transition and into innovation in general?
Yeah, absolutely critical. I think one of the follies of so-called clean tech 1.0 back in the sort of late aughts and into the early 2010s was that it was, sort of a Silicon Valley-led movement, right? It was a bunch of prior software investors from the Valley who thought they'd, we'll try our hand at climate tech and clean tech and hard tech, frankly. And, there were very few real success stories from that period. Tesla's actually one of the few that made it out. And I think it's because the mentality was, we can do this ourselves. We're disruptors. We don't have to work with incumbents. Screw the utilities. We'll put them out of business anyway. And when you're dealing with infrastructure that is in the hundreds of millions to billions of dollars range, that has to have a life of 20 to 30 years, some cases longer, that requires continent-spanning networks in order to serve customers, you can't not work with incumbents. And so I think I'm encouraged that I see so many incumbents putting money to work, putting resources to work, looking to partner with startup companies and growth stage companies, looking to maybe hedge their core business, looking to expand their core business. We're just never going to get through this energy transition, and certainly this climate tech 2.0 period without the incumbents being really actively involved.
When you talk about tech, one of the things that Jeff Miller was, I think he coined the phrase, or at least will popularize it from our yesterday's meeting, which is, we have digital technology. I teach that here, and it's, you can go to your dorm room or your garage, and it's pretty clean and easy, and you're doing bits that are not drill bits. You're doing bits that are binary bits. The real innovation for energy, though, might come from not this sort of digital tech, but from what Jeff called hard tech, which means actual physical products, things that are hard, things that would reinforce what you said, which is it's got to be startups and entrepreneurs working with some incumbents, working with Halliburton Labs, say, to get the technology that's difficult, like drilling equipment type technology. Do you see the energy space being one in which hard tech is something we have to understand as much as digital tech?
I mean, absolutely. We're not going to solve this problem with software. Though I will say an amalgam of software and hardware is what's needed, and there are software solutions out there that can make a difference. Usually hybrid solutions that involve novel hardware that also has smarts embedded within it that were not possible 5 to 10 years ago is going to be a big part of the answer. But absolutely, I mean you can't email an electron, right?
Right.
So we need, and hard tech is hard. It is more capital intensive, and scaling up that kind of any kind of hard tech solution requires just a different level of risk and a completely different execution skill set, really an operational skill set than building a software company.
I know we hadn't really planned to take questions, but I see there's so many experts out here. We don't have microphones, but raise your hand and shout out if you've got a particular question, especially about Third Coast. Anything? Yeah, go for it. Yeah. And I'll just repeat it. So.
Geothermal power or geothermal energy in general. Yeah, it's a really interesting resource. Geothermal power is also really hard. Today in the US, we have about 3 gigawatts of geothermal power. That's relative to peak demand of about 800 gigawatts. It's mostly in California and Nevada, and it was, I think, about half of the geothermal resource in this country was found by accident, actually by people drilling for water, and then steam came out of the ground. And so we've only really been able to tap geothermal so far, where it's just you have this really rare confluence of naturally occurring, water and heat that's pretty close to the surface. Going deeper and creating those types of reservoirs, in some cases leveraging technology and approaches that have been, now really perfected by the oil and gas industry and hydraulic fracturing, directional drilling, et cetera, is really the next step for the geothermal industry. There's not a whole lot of companies that are making great progress in that domain. One is Fervo that's gotten some attention recently. There's a handful of others that are actually trying to take the next step and drill even deeper, let's say. I mean, hypothetically, if you drill, I think it's like 10, 12 kilometers down just about anywhere in the world, you can tap into sufficient heat to make power. It turns out that doing that is probably about as hard as getting nuclear fusion, right? So there are more companies trying to do nuclear fusion than there are trying to drill down 10 kilometers into the earth and make power. That'll tell you something. There's another resource, though, I do want to mention, geothermal, heating and cooling. You don't have to go too far down into the earth to have a pretty constant temperature that you can use to heat and cool a building. And I actually am a big believer that we are under-investing in and underutilizing that resource for not energy production, but for building thermal management.
What else are we investing in?
Under-investing in, yeah, that's a good question. So yeah, I think actually geothermal power as well. As a nation, we are dramatically under-investing in nuclear power. I think of nuclear as it's a magical technology. Oh my goodness, what if we had this magical power generation technology that was carbon-free, and we actually invented it in the 60s and deployed it before we had, computer spreadsheets, and it's still operating today at 90% capacity factors, and then we just gave up on it, while other countries have not. I mean, I know I'm beating the drum and probably preaching to some of you in the choir here, but it's absurd that we have not been able to build more than one new nuclear power unit in the country in the past 40 years. And this is not a technology problem, again. This is a regulatory problem. And I'm encouraged. I personally believe that the 2030s will be a decade of nuclear renaissance. You heard it here first. Because we're going to need to. I think as people get desperate, and recognize that we're not going to hit net zero targets without relying on nuclear, then both the public and governments around the world will turn back towards it. Now, that might not be conventional nuclear power. It might be next generation. It might be fusion power. Fusion is also extremely hard, but there's a surprising number of very credible efforts that have a chance at the very least, demonstrating the scientific milestone of energy break-even, I think, this decade, and potentially into the 2030s commercializing. So, not a sure thing. This is fusion, but remarkably good progress.
What about modular, smaller nuclear power generation? Would that help both on the regulatory and the grid and maybe even in the NIMBY issue?
I'm a little less excited about SMRs, small modular reactors, I think, than the average nuclear file. Mainly because I don't think they really address the regulatory problem any better than large nuclear reactors. I mean, if there were, it's a question of public perception, not reality. The reality is our existing nuclear technology, Gen 3 technology, is already probably, by almost any metric you could choose, the safest energy production technology, globally speaking. So we don't need nuclear technology to be safer to deploy it. We don't need it to be smaller to deploy it. The theory behind small modular reactors is that you could start to produce them in more of a manufacturing fashion, in a serial fashion. More of the components could be manufactured than sort of engineered, assembled as a big construction project. But in order to realize economies of scale from that, you have to do a lot of them. And so the last problem I'll say with SMRs is there's probably 80 to 100 different companies that have their own take on next generation nuclear, on small modular reactors, on micro reactors, et cetera. And I actually think we could do this a lot better if we just built 5 more reactors that we already know how to build. So that's my take.
Right, except there's also an economic issue with the really big reactors. I know you say it takes a while for the smaller ones to reach scale, but besides the regulatory issues, isn't it hard to finance now a nuclear power plant?
Yeah, there's the financial risk factor, which is related to the regulatory risk factor, which is that the planning timeline is long, the construction timeline is long and uncertain, and everyone looks at the Southern company experience. Southern was our founding utility investor, by the way. They look at the Southern experience with Vogtle, and they say, "Oh dear Lord, I don't want to go through that myself. My regulators would not allow me to rate base that kind of cost." But I'll tell you what, I have a lot of friends at Southern Company, and I've certainly spoken with many of them, and they're happy they have that reactor online today, despite everything they went through, because of the amount of power demand growth we're seeing today. If they didn't have that reactor online, they would have to be turning away more customers, saying we don't have enough power for that marginal data center, and in particular, customers who want clean energy. So I'm hopeful that, again, there's no easy way of doing this, but with a combination, you need a combination of policy, a change in the regulatory construct, and frankly, a bunch of bold companies who are willing to be the next people to start building. Mm-hmm. And it's probably going to have to be something where it's a full industry concerted effort along with the government. It's not going to be something one company does.
Right. Was there any other comments or questions? Yeah. Where are we going to go on the transmission and distribution side, not just the primary side?
Yeah, I mean, it is the bottleneck, right? Again, we can produce clean power. The question is, how do we get it where it needs to go? The cheapest places to build renewables are out in the middle of nowhere, where there's lots of open land and it's really windy and sunny, and people generally don't want to live. And we're already seeing in Oklahoma, for example, the difference between prices in western Oklahoma, power prices in eastern Oklahoma is stark because western Oklahoma is flooded with wind and you can't get that. You're having to curtail wind energy. 10% of all wind energy generated in those plain states was curtailed last year, meaning it was just wasted because it couldn't get to market. The problem with transmission is, again, I have a lot of friends in the utility industry. The transmission part of the utility business is the most small c conservative part of a conservative industry out there, and for good reason. They're operating, high voltage infrastructure. Again, it needs to last, 70, 80 years in some cases, and so they're very hesitant about it. It's a slow adoption cycle. It's been a tough one for venture-backed companies, whether we're talking about new conductor materials, which I think have some promise, software which can make better use of the conductors we already have, which has some promise. Again, I think this is going to be a slow burn. Actually, one company we've invested in, I'll say, is called Infravision. It's actually focused on building transmission faster. They're using drones to actually string conductors, string transmission lines, which has never been done before. They're actually doing, basically, they're now responsible for, I think, all of the new transmission built in South Australia, which is where this company got started, is being built by drone. They can build much faster, cheaper, with lower safety hazards for people stringing conductors. So, it's not going to solve the entire problem, but every little bit counts.
And finally, we're at sort of a Third Coast summit, Third Coast pitch contest, the Gulf Coast, and especially this region. Obviously, Houston is huge in the energy business, but the Gulf Coast of Louisiana, Mississippi, very involved and has a whole lot of infrastructure of legacy energy. What are the opportunities you see in this ecosystem to be a big player in the future of clean energy?
So, something that's been puzzling to me since I got into the venture capital business and in clean tech or climate tech in particular, is just the number of companies, the share of companies that are coming out of just 2 university ecosystems. Like, probably a third of the companies we talk to have some sort of foundation in MIT or Stanford. And it is just not the case that all of the smart people in the country are concentrated in those 2 locations, right? There's great engineering schools other places. There's great business schools other places. There's talented people who know how to build things, especially other places. And I think I've thought a lot about what it is about those 2 regions that makes them so successful. And it is the confluence of, you have a lot of bright young people coming out of universities with a strong technical background and with a strong business background who are right next to each other. Mm-hmm. You have venture capitalists circling like vultures around them, and you have a financial community that is supporting them, and a business community as well. That can be replicated and then some in a place like the Gulf Coast, where I think the next stage of this big climate tech endeavor in general really is about scale and deployment. And a region like this that actually knows how to build big things, like, you don't see big industry outside Boston or outside, Palo Alto, right? Like, this is the kind of region where if the business community leans in particular, the industrial community leans in, I think you could lure a lot of talent. I think you could lure some of these companies, especially to take the next stage of their journey. Like, oh, I got founded at MIT. That's where I did my PhD. That's where I met my co-founder from the business school. But then when we actually wanted to hire our first 100 people, we did it in Louisiana, potentially, right?
From your lips, Andy, thank you so much. Really appreciate it.
Yeah.
Great. Great.
Yeah, thanks.
Thanks a lot. I now turn it over to. All right, Dale, Scott.
Got a mic? All right. Thank you, Walter. Thank you, Andy. As you can tell, Andy's got a phenomenal perspective on the innovation landscape and the investing landscape associated with that. We appreciate having him here in New Orleans with us. And, of course, Walter Isaacson. Walter and his wife, Kathy, got us connected with Idea Village and New Orleans Entrepreneur Week. This is our 3rd year here. This is our first time hosting a pitch competition at Tulane University, but it's a phenomenal setting, and it's a phenomenal group that's doing some good work for the Gulf Coast, and we're really pleased to be affiliated with it. So at this time, I'd like to invite the fellow panelists to join me on stage for the next part of the program. I'd also like to introduce the Halliburton Labs Advisory Board members that are in the audience today. So we'll start out. John Grotzinger, professor at Caltech University. Please give John a round of applause. We've got Reggie DeRoche, president of Rice University, with us, advisory board member. Pulikesh Mukherjee, partner at Imperative Ventures. Jennifer Holmgren is online. She's the CEO of Lanzatech. And our next two advisory board members, I'll actually invite to come up on stage as part of today's panel. First, let me introduce the chairman of Halliburton Labs Advisory Board and also Halliburton's chairman of the Board of Directors, President, and Chief Executive Officer, Jeff Miller. Another Halliburton Labs Advisory Board member, Maynard Holt, who's the CEO at Veriton. Our next panelist is George Coyle, managing partner at EIC. We're delighted to have Paula Gant, president and CEO at GTI Energy. And Mr. Jonathan Glass, Deputy Director of Commercialization at ARPA-E in Washington, D.C. So we're really looking forward to a fun format today. We've got 9 great pitches from finalist companies from around the world. They'll have a 5-minute pitch that's pre-recorded. Then we'll invite the founder on stage for some Q&A session. As Scott mentioned, the online audience can submit questions as well as the in-person audience. We're really excited to have them here with us in New Orleans today. And so let us get to the first pitch. Our first pitch comes to us from AtmosZero, a Fort Collins, Colorado-based company. AtmosZero is decarbonizing steam production for process heat with its development of modular heat pumps to generate industrial steam up to 200 degrees Celsius, covering 50% of the industrial heat market. The modular design allows customers to eliminate on-site construction cost. Here is COO Ashwin Salvi to tell you more about it.
Hi, I'm Ashwin Salvi. I'm one of the co-founders and the chief operating officer of AtmosZero, where we focus on industrial scale decarbonization. At AtmosZero, we're delivering low-cost decarbonized steam for industry. We replace fossil-fueled industrial boilers with a drop-in electrified steam boiler that eliminates on-site carbon emissions. So why steam? Turns out steam touches every part of our life, from the food and drinks we had at dinner last night to the clothes you're wearing today. Steam is a ubiquitous energy carrier that cuts across many different industries. In fact, it accounts for 50% of process heat in industry, which results in 8% of global primary energy use, or 2.25 gigatons of emissions per year. Steam drove the Industrial Revolution over 180 years ago. Since then, we've been making steam the exact same way. We burn fuel in a boiler, make heat, and transfer that heat to water to make steam, and then use that steam for a variety of different processes. It's clear that if we want to achieve our climate goals and the benefits of an industrial society, we need to decarbonize steam. We're doing so by redefining boiler room efficiency. Our boiler is twice as efficient as today's boilers. If you consider how we make steam today, we're generally using combustion-based boilers fueled by natural gas or fuel oil, and in some cases even coal. That has some amount of inefficiency associated with it. On average, today's boilers are about 80% efficient. These combustion boilers, however, produce CO2 and other emissions on site. If you wanted to decarbonize these boilers, the only real solution out there today are electric resistive or electrode boilers. Yes, these are more efficient than traditional combustion boilers. However, they're not as efficient to offset the increase of fuel cost due to the higher cost of electricity compared to fossil fuels. That being said, this technology is actually starting to see increased demand with an expected CAGR of 15% through 2030, even with its higher operational costs. What we're doing instead is instead of incurring efficiency losses, we're producing efficiency gains. We do this with a product we call Boiler 2.0. Boiler 2.0 is a modular air source steam generating heat pump that pulls in heat from ambient air and upgrades it using AtmosZero's proprietary heat pump all the way to 200C saturated steam. One of the key enabling features of this technology is that there's no waste heat required. What that lets us do is solve two main barriers to adoption for decarbonized steam. That is, using our technology, we're operationally efficient, but also capital light. We don't require any sort of bespoke engineering per facility. What that lets us do is create a product, not a project. By creating a standardized product, we can now mass manufacture our technology and reduce the cost of our system compared to competitive technologies. In addition, because now we are a standardized product, this device looks the same whether you're in the US or in the EU. So if you're a manufacturer with multiple manufacturing locations globally, you can now standardize your decarbonization solution and have the product install, integrate, and run the same way in all of your facilities. This also standardizes the training to operate, service, and maintain the boiler. Our first customer taking our product to market is New Belgium Brewing. In the first quarter of 2025, we'll be replacing 1/3 of their steam demand with one of our units, making process steam in revenue service. After a successful demonstration, we'll do a full deployment of not just replacing steam in their headquarters in Colorado, but also their 3 other locations. That's the beauty of being a standardized product. We can deploy and integrate with the facility in exactly the same way at all the different locations. We're a company focused on climate action, and for impactful climate action, we need to scale for global impact. To help with this, we have prototyped and tested our first system, a 650 kilowatt thermal system, the same one that will be deployed with our first customer site within the next few months. We have established key supply chain partnerships to help with technology development and manufacturing. We've also established world-class research with our partnership with Colorado State University. Since we're solving a global issue, we've also established a subsidiary in the Netherlands to continue to commercialize our technology in the EU. What we're doing next as a company is transferring our technology from proof of concept in our facility into our customers' hands while setting up for manufacturing. We're looking for customers and partners that want to decarbonize industrial steam and execute on climate action. The 3 co-founders all individually have over 15 years of industrial experience in the clean tech world. We know what it's like to be in a startup realm, as well as what it takes to commercialize technology. And that's why we're able to scale our technology and get it out the door in less than 3 years from inception. We're AtmosZero, and we're driving the next industrial revolution. Thank you so much for your time.
And now the panel welcomes Ashwin Salvi. Good to have you here.
Hey, thanks.
Welcome. I'm going to lead off. If you think about, what could be argued a crowded space, what do customers tell you that's different, or how do you see your product solution differentiated?
Yeah, so we kind of mentioned this earlier, but the way that we integrate with facilities, the product we're creating is a plug-and-play drop-in solution. So it really minimizes facility downtime and the integration efforts that you would see with decarbonized solutions today. Plus, it's twice as efficient as today's electric-resistive boilers. So the operational costs, what's most important is operational costs throughout the year, ends up being significantly lower for our solution.
Ashwin, it's great to have you. Quick question. As you think about this, and you think about your business model, it looks like you want to build them and install them. You're going to manufacture and get them in. Did you think about a different business model of, I got great technology, I'll license it, and then I'll let someone else do all that hard stuff? Like, how have you thought about the business model?
Yeah, that's a great question. So certainly we're open to manufacturing our own assets today and selling those assets directly to the customer, but also licensing to third parties to either manufacture it for us or as a service where we can sell our asset to a company that can then go out and find a customer that they can do performance guarantees for.
Ashton, glad to have you here. One question I have is about your heat source. Since you're doing this as a heat pump, I had an experience during the Texas cold freeze where with my heat pumps I couldn't get my house above 50. So for an industrial process where reliability is so important, what's required for air temperature for you to get to these levels of heat for industrial processes?
Yeah, I mean, being a Colorado-based company, it gets cold there. So we're certainly designing our product to be able to run down to very cold ambient temperatures. What's most important in a manufacturing setting is to make sure that steam is available. If you don't have steam, you can't manufacture. So we're designing our first system that goes out next year with our pilot customer down to -10 Celsius, and then our full product the year after that in 2026 down to -20.
And so what's the heat source at that point? Is you literally have enough differential at that?
Yeah, ambient air is still our heat source at that point. And so to help with the reliability side of things, these systems can run in parallel with other either assets on site, or if we want, we can even put in the electric, just the boiler as a backup. So if it gets much, much colder than that, those maybe 1 day, 2 days a year, we still have steam.
Ashwin, it's really great to have you here, excited about what your team's doing. Our team's excited about some collaborations that we have at GTI Energy with y'all. And this is a great example of a drop-in equipment, like a drop-in fuel. It's going to be how we speed to our goals on energy transition. A key part of that is how are you thinking about de-risking the prototype application for customers in the field? And so that, because that's a really important part of getting your technology used and useful.
Absolutely. Again, steam is critical to manufacturing processes, and therefore it must be a reliable and durable product. What we've done is been able to create an at-scale prototype at our facility today. So the 650 kilowatts thermal that we're making as a first product, that's what we have in our facility. The temperatures that we're achieving for our first product, that's what we're achieving in our facility too. So we're running that full out, making sure that the parts that we're creating and the assemblies that we're making together can be run reliably. But as we start deploying more and more units into the field next year with our customers in pilot configurations, we get more and more data points. We're also creating test beds for making sure the devices we have in our system can continue to be run in a durable set point. So run these things 24 hours a day, see what the wear and durability look like, work with our partners and suppliers to help mitigate any challenges that might arise.
Ashwin, great to have an RPE alumni here and a fundee, so excellent. And Andy, thanks for the nice shout out earlier too. So talk to us about the thermal battery companies that are out there that are also raising capital that we've heard about and that we're funding some of. How do you compare to thermal battery companies? They have the advantage of being able to manage, intraday energy prices. And so how does AtmosZero address that?
Yeah, actually, we see ourselves as collaborative with those kind of technologies, like the Rondos, the Antoras. They're fantastic folks working in that technology space, and I think they are a great technology to help provide extremely high heat for applications. So if you look at cost trade-offs, which I can get you, I don't have it right here. Temperatures below 250 Celsius, that's where the efficiency of a heat pump really pays off. That's where our levelized cost of steam is significantly lower than that of energy storage, even with extremely low pricing from the grid and from storage materials. What's really nice is that we can still partner, so we can use that to store heat and maybe use that heat to source our heat pump from throughout the day, but not necessary for the economics to work.
Thanks.
Ashwin, congratulations with the traction that you have there with the brewery in Colorado. Can you just help us think through, of all the other industrial applications where this technology might go next? What kind of feedback have you gotten from the marketplace, and what are you kind of selecting for where you've sort of found best fit?
Yeah, there's a reason we focus on steam. Steam is this cross-cutting energy carrier. It's multi-sector. So in my video, which, sorry for my voice being all cringy, it's food and beverage, it's chemicals, it's pulp and paper, it's textiles. Everything we interact with on a daily basis is touched by steam. That's 8% of industrial use cases. 8% of global CO2 is from the industrial side. 4% on top of that is district heating. So things like campus networks for steam, for the built environment, like buildings in New York, Local 997 now banning natural gas for boilers in multifamily or office spaces. These are all steam-driven systems, and so there's a huge opportunity here, right? So we talked about food and beverage, our brewery being our first customer that we're going to market with next year with New Belgium Brewing. But there's actually 2 more customers that aren't public that are in the chemical space. And this is both in the US and in the EU. So there's a lot of great opportunity where we can just have a plug-and-play solution, especially for those folks that have multiple locations globally. Trying to do a bespoke engineered project for one facility and then do exactly the same thing somewhere else, and then somewhere else, ends up being extremely expensive and extremely long in terms of deployment time frame. What we have with a standardized product, drop in, plug and play, off to the races you go.
Thank you. When we think about companies, and I think about Halliburton Labs, if you had to accomplish one thing next year, what would be the one thing that you say, wow, you guys could help us with this?
Yeah, so, So we just raised our Series A, and what we're doing with the Series A is really translating from our proof of concept to putting product in customer hands. That's where it's the most important, right? That's what we've designed our company to do in less than 3 years. Go from a concept, putting product in the real world, making a real world impact. At the same time, what we're doing is planning on manufacturing a facility. So to be able to meet the demand that we're seeing from our customers in 2025, 2026 timeframe, we're also developing simultaneously, as we're putting product in customer hands, plans for growing manufacturing to the tens to the hundreds of units per year to get these units out the door and making real world impact. That's where I think we can partner well on.
We've got to leave it there for now. Please give Ashwin a round of applause. Thank you for being here with us in New Orleans, Ashwin. And for those in the audience, I know there's a lot of global industrial steam users around and investors and others that may be interested to get to know him. He'd be excited to meet you. Thank you, Ashwin. Our second pitch is from EQON, based in Norway. EQON is developing an advanced hardware and software system that helps customers reduce emissions and energy costs by controlling industrial electric heat that improves efficiency by providing only the energy needed to optimize heat cable performance. Here's CEO Mikhail Lovik.
Global energy consumption is expected to double by 2050. That means we need new clean energy sources and we need energy efficiency technology. 66% of the energy consumed by the industry is used for heating, and heating is the single largest source of CO2 emissions on the planet.
For years, industries and cities have wasted energy, sometimes without even knowing it, spending a huge amount of energy on removing snow and ice to ensure the safety of citizens and personnel.
Heat trace cable is a common use source for heating in the industry, and it's designed to maintain ice-free surfaces at extreme temperatures. The problem with heat trace cable is that it's designed for worst-case scenarios. Most of the time it consumes a lot more energy than what it needs for the job at hand. We have invented this device, which is a combination of hardware and software, and it allows us to provide the exact right amount of energy to the heat cables. As a result, our clients can save up to 80% of the energy consumed by the heat cables, at the same time as reducing maintenance costs and increasing lifetime of the heat cables.
EQON allows you to individually control and monitor every little detail of the heating process. By eliminating energy spikes, the power consumed by the heat trace cables is dramatically lowered, reducing the overall need for power. The system can even perform and predict maintenance requirements and identifies potential errors before they occur.
Our business model is a combination of hardware sales and a software-as-a-service solution, giving our clients the insight that they need at the same time as optimizing their energy consumption. Our market is huge. The potential market value is estimated to about $2 billion a year, and it stretches from smart city to food and chemical production and other process industries. So what have we done so far? We have created this fantastic product, we have certified it, and we have had several successful pilot projects. We have a strong team and a strong business model, which we believe is the right mix to take the company to the next level. We have set up a strong distribution network, and we have now started deliveries to our first commercial contracts. And one of the first projects that is already delivered is the sidewalk here in our hometown Stavanger. Only this small project alone saves the local municipality for thousands of dollars a year, allowing for more services to enhance the quality of life for the citizens. The company is now ready for the next phase, where we start scaling sales and we are going into mass production, producing thousands of units. It's ideal for EQON to collaborate with a company like Halliburton. We believe this collaboration can be a crucial factor for our success. We need experience within procurement, quality assurance, and mass production. So we are now ready for the next phase of the company, and we are raising capital, and you have the possibility to join us on our journey.
EQON provides market-leading precision in heat management with a maximum deviation of 0.2 degrees Celsius. In short, EQON reduces the CO2 footprint, lowers material consumption, saves energy, and increases your profits.
And it's our pleasure to welcome Mikhail Lovick from Stavanger.
Thank you very much. The pleasure is all mine. Thank you for having me.
Mikhail, welcome. I'm glad to tee it off here. I guess as I was watching this is very exciting. Could you just talk to us about the customer interaction when you try to go make a sale? How hard is it for them to evaluate, purchasing EQON, installing EQON? Will EQON really work for them? Like, how hard is that sale? And just talk to us about, you compete with some big industrial players that try to manage people's buildings and facilities and stuff like that. Can you be friends with them? What is that dynamic like? How well do you interact with those players?
So I think, first of all, the first sales are a lot harder than you expect. I think every founder will have to admit that. So what we see when we go we've chosen kind of the hardest route. So we go to big corporate clients, and we've gone to local municipalities, and they're not considered the easiest first clients to go to. But what we've experienced is that many of them have spent quite a lot of time to see if they can find a competing or an equal solution. And they can't. They don't seem to find the product that has the complete value proposition that ours does. So when they spend a lot of time doing research, and when they first conclude, it's a very easy sale because we can save some of our clients up to 80% of the energy cost that they spend on heating. So that part has been kind of it's a small revolution almost, and it's hard to believe for many people when they see the first calculations. But then, we have now proven the technology through various pilots in different areas, so both in sidewalks and on ships and on oil platforms. So we have kind of a wide spectrum of references to show to, so it makes it easier. When it comes to working together, like with a large, we look at kind of the installers, so a company like Halliburton or other big service companies, they seem to like having new businesses like ours, entrepreneurs coming up with good ideas so they can have more business and putting it forward in the market. So we have a few back home in Norway that we actually collaborate with to install it for us, and they also push it into the market for us. So that's been so far very good for us.
Yeah, that was actually going to be part of my question. Is I noticed a lot of this was offshore or in the shipping industry. We've deployed technologies in this space. It's pretty hard to actually get one of your people into those environments to begin with. How plug and play is this? How much setup time is there? Because that could be a real barrier to adoption. So how are you handling that?
So the more professional the client, the easier the installation, so to say. So there's a lot of small electrical cabinets around in the colder cities, like in New York or our hometown, Stavanger. Those cabinets are not maybe ideal for us, so it might need some engineering. But it's still a very low percentage of the cost. The installation part is down to 10% of the total cost of the project. On an oil platform, for instance, or in a process plant, if you go to, say, a Coca-Cola process plant, they also use a lot of heat cables. It's just plug and play. You can click it right onto the DIN rail in the existing cabinet and connect it to the fuse, and it's working. So it's a very easy. We've tried to make it as easy as possible to lower our own entry into the client's sales department. Yeah.
Awesome, thanks. That plug and play aspect is really vital for the efficacy and scale, adoption of these. It seems like in your muni applications, realizing that's quite complicated working with municipalities, you're focused on the heat cables and in these other applications. How are you thinking about the applicability of the solution in other electric heat resistance applications beyond this?
So for us, being from the North Hemisphere, kind of, where it's a lot of cold and cold, the cold is making us use a lot of energy. For instance, for heating outside, it sounds crazy that we need to heat our sidewalks, but it's done a lot. So that's a very obvious kind of first route to go. But this control system can control any resistive heat load. So we are marketing it now towards heat trace cable because it's also a very, very big market for it. any process industry that deals with making chemicals or even liquid foods, they use heat race cable around their pipes to keep the flow at a constant temperature. That's ideal clients for us because we're precise when we manage the power coming out in a complete different way than any competitor. So we have, I think it's 10 times higher precision rate on the pipe, on the management of the heat than any competing system. So also that market is a big market. But it's more difficult to come to Coca-Cola and say, hey, we'll save you 7% of your cost and keep you at a very high precision level. It could be that that's a very big market for us, but it's something we have to move into in the next phase of the company.
Thanks for all the comments. Question I have, just to clarify, is the solution a kind of greenfield, the solution that requires both the new cabling and the controller and software, or can you drop into an existing installation and just come in with the new controller?
I appreciate the question because it's also something that I don't say that much in the pitch. I've thought about after. In a greenfield application, this system is very unique in the way that we have invented what we call a bidirectional power switch. And that allows us to use twice the size of the heat cable in an installation. So in the greenfield installation, the installation cost for all the parts, then the heat cable itself will be half of any competitor. So that's a big value proposition on its own. In a brownfield application, which is the largest market and the easiest market because people already spend all that energy, it's already on. It's the same plug and play, and we will also we will increase the lifetime of existing cables by about 50% by applying this, since we're taking down the consumption and the load on the cable to a big extent. Yeah. I hope that answered the question.
So when I think about installation, a little bit the last question, solving for heat quantities, how is it, is it monitoring the environment, or is what's the software doing that keeps it off, on? Is that all part of the solution? Is that how you think about that?
So there are competing systems who also regulate these cables, obviously, and they are very much operating with an on and off thermostat like we have in our hotel rooms, for instance, if you have heat on the floor. This system functions like a dimmer. So if you have a light, a LED light that you can dim, that's what we do kind of with the heat cables. And that's what we have patented. So we can give the power cable 0 to 100 power based on any input that we get. So our algorithm calculates a lot based on actual temperature on the surface, ambient temperature. It can look at the weather forecast and it can predict how it's going to be in 2 days. Should we start heating now so that when the snow comes it's already warm? That's kind of a big mix, and it's a massive complex calculation behind the algorithm and the system.
Okay, thank you.
We're going to have to leave it there for now. Thank you, Mikal.
Thank you very much. Thank you so much.
It was great to have you here. He's here from Norway. If you'd like to learn more about the EQON solution, he'd be delighted to discuss it with you. Next, we have a quick update from an existing Halliburton Labs participant company, Redshift Energy. Redshift uses plasma energy to produce hydrogen from hydrogen sulfide. And we have Scott Gale with Redshift CEO and Tulane MBA, Howard Nelson.
Thanks, Dale. Yeah, we've got Howard. With the AV system here, we're going to just bring Howard right to the middle of the stage. And Howard, thrilled to have you here. You've been with Halliburton Labs for a few months now. Not too long ago, you were up on this kind of stage. Tell us what you're excited about in 2024.
2023 was a really exciting year for us because we got 2 grants from the federal government to prosecute our technology. Our mission is to ensure the affordability of energy transition and make sure our technologies can be applied across the entire value chain for petrochemical and oil and gas. We take plasma chemistry and we use that to produce low-cost hydrogen. And this year we're going to be closing our Series A. We're going to be installing 2 pilots, but for both of our programs, we have one for recovering hydrogen from hydrogen sulfide, and the other is producing syngas from carbon dioxide and methane. Our assumption here is that companies are not going to be making their decisions based on tax credits. They're going to be making their decisions based on profitability, and our systems are designed, regardless of which incentives are in place, to achieve low-cost, profitable performance of our technologies for the use in taking these waste gas streams and making them into final products. Our technologies have the ability to supply about 25% of the nation's hydrogen needs over the next 40 years. So we're very excited about our progress, and we're very grateful to be part of the Halliburton Lab system and all the support that we get from you guys.
Awesome. Good to have you here, Howard. Anybody that wants to get in touch with Howard, let us know. We can pass along his email. Excited about what you guys are working on.
Thank you.
All right, Dale, back to you.
Thank you, Howard.
Thank you, Scott. Thank you, Howard. Moving on to the third pitch. It comes from Ortoro Energy in Boulder, Colorado. Ortoro is focused on strengthening grid resiliency and enabling renewable energy deployment by providing long-duration storage in any location. The company has developed an innovative flow battery electrolyte that is lower cost, lower toxicity, and higher energy density than vanadium electrolytes. Ortoro's fluids can be used in existing flow battery hardware designs. Here's founder and CEO Mike Marshak to tell you more about it.
Hi, I'm Mike Marshak, founder and CEO of Ortoro Energy, and we're revolutionizing energy storage with a new battery chemistry. Retail electricity rates are rising faster than inflation to support growing electricity demand and increasing supply of renewable energies. After decades of neglect, the grid needs a massive build-out to upgrade the transmission and distribution systems, and this can take decades to deploy. Ortoro's flow battery can minimize the need for massive build-out of transmission infrastructure by providing local energy storage for both electricity generators, like utilities, and consumers, such as businesses. Ortoro's technology can support a decentralized grid due to its core chemistry that solves all the challenges with scalability, localization, efficiency, and safety. Moreover, it offers the lowest cost and highest performance battery materials physically imaginable at scale. That's why the DOE is investing millions of dollars in our technology and company. Energy storage is a massive market opportunity, waiting for the right technology to come along. McKinsey expects it to be potentially a multi-trillion-dollar market by 2040. The only problem is that existing batteries aren't up to the challenge. You might ask, do we really need another battery technology? And the answer is yes. Flow batteries are different from other battery technologies because they store energy in liquids that can be stored in tanks and pumped in and out of the battery cell. What that does is it decouples the power component, which is in the cell, with the energy component, which is in the liquids. If you want to double the amount of energy that's stored, you just double the volume of the tanks and you double the liquid. It's just like an internal combustion car. If you want to drive twice as far, you don't need another engine, you just need more gas. The same way with these batteries here. This decoupling of power and energy means we have a very different cost structure compared with traditional batteries. Instead of having to double the amount of batteries in order to double the storage, our costs asymptote down to the cost of the materials and the tanks to hold them. So if you look at this cost curve here, we can outcompete lithium ion for longer and longer durations beyond 4 to 6 hours, which is where the market is really moving. Moreover, our materials are operating in water at neutral pH. It's making it non-flammable, non-corrosive, non-combustible, and non-toxic. The Department of Energy has independently evaluated that we're one of the lowest cost energy storage systems and the lowest cost flow battery technology on the market today. Moreover, we also offer leading industry performance in terms of cell voltage, efficiency, and power. So how do we do it? Easy. We use iron and chromium, the number 1 and number 3 most mass-produced metals globally, and combine that with a chelating agent, an organic material that's produced from natural gas precursors. Based on those two things, we have both the lowest cost and highest performance materials physically imaginable. The materials were developed in my lab at the University of Colorado Boulder, which I've since left to work at Ortoro Energy full-time. We were part of the same ARPA-E cohort as some other major players in the energy storage field, and we were partnered with Raytheon Technologies Research Center, who helped us demonstrate the performance and efficiency of our battery, which you can see having cycled hundreds of times to the right. Over that time, it's important to note, they never observed any loss in capacity despite doing things like heating it, turning off rebalance systems, and other things to essentially try to break the system. Following that, we received over $4 million from the Department of Energy's Advanced Manufacturing Office, which has helped us to scale the technology, scale the chemistry, and take the technology to kilowatt scale field demonstrations, so TRL4 to TRL6. We're in the midst of that project right now. We've also recently received last year a cooperative research and development agreement with Pacific Northwest National Lab, State of Colorado grant, SBIR grants, part of some incubators and other competitions, including this one. So we've got a lot of momentum behind us, and we're already at this point where we can make metric tons of materials with our manufacturing partners. Speaking of partnerships, we're working with a whole host of different partners to help us reach our goals as quickly as possible. We're seeking to raise $5 million in a seed round to help us build out a 10 kilowatt field demonstration unit and get us started towards a 100 kilowatt system. In summary, we expect to achieve rapid scale-up of our revolutionary technology by leveraging partnerships, government funding, and the existing battery and chemical supply chains.
Welcome, Ortoro founder and CEO Mike Marshak. Thanks for being here.
Thank you.
Hi, you already showed that according to your estimates, it's going to be the lowest cost of any of the other type of battery systems. How dependent on that is how often is it dispatched? In other words, if you're not dispatching every day, what % energy losses do you have? Has that been calculated into your process?
Yeah, we've seen when it's not being used at all, 3% per month self-discharge rate at room temperature. So it's pretty low and that doesn't permanently lose capacity. That's just a discharge rate that we can reboost. In terms of the not using the battery, I think there's a lot of really interesting emerging markets that people aren't thinking about in terms of what could you do with energy when a battery potentially is not being used. Things like EV charging come to mind. If we can put a battery in a community where that would be valuable. Even things like cloud computing or even Bitcoin mining could be something that you could use to generate revenue if the grid isn't demanding the battery at that time.
Good morning. Thanks for being here. You talked about leveraging partnerships, and it seems an important application of that is learning by doing with others of how your flow battery is going to be used, because it's a pretty competitive space with some other options out there, right? So I'm interested in your partnership with Raytheon that also has their own flow battery, and how you're thinking about leveraging that, particularly as relates to how the battery is going to get put to use, and thinking about one of those big customers like the US government and others that you might see Raytheon partnering with on deployment of these kind of technologies. How are you thinking about leveraging that partnership?
Yeah, that's great. Yeah, we've been really fortunate to partner with them since the inception, or just past the inception through ARPA-E. And they've been a great way to help us scale and demonstrate. They have test stands based on vanadium. And so some of our initial work was just sending them our electrolyte materials. And everyone we've sent it to, whether it was Raytheon or Pacific Northwest National Lab, they put it in just a standard vanadium stack. And it works beautifully in higher voltage and higher power basically the first time they try it out. So we're looking to leverage that knowledge base and essentially the 40 years of vanadium flow battery development to be able to just effectively use our materials as a drop-in replacement for vanadium. Now, there's other things that we need to do to change that in terms of battery monitoring. Having a higher voltage just changes some of the electronics involved. But overall, being able to leverage the ecosystem that's developed around vanadium has been really helpful in getting us to market quickly. One key thing I think is that in the past, other companies have had to develop their own flow battery stacks. And that's a key challenge because that's got electrodes and membranes and everything else. We can take advantage of multiple different suppliers of stacks, and we just have to play the trade-off. Everything works. It's just a matter of efficiency and power versus cost. And so there's the Mercedes type flow stack or the lower cost flow stacks that may be lower performance. But we can play all those trade-offs and really just look at different components as like, we'll flow our liquid in, we get power out. So that's really been helping to scale our technology and why I think we can do that much more cost effectively than others.
Mike, great to see another ARPA-funded technology. Very exciting. I want to go in a different direction. Something I've seen for long-duration energy storage, almost as important as the hardware, is the software side, being able to go to a customer on specific use cases, you know, kind of moving away from the generalities of a levelized cost of storage and getting into the specifics in that locality, given energy pricing, given cycling duration, you know, asset usage. How are you approaching that to be able to go make a use case? I mean, that's what like Form has done. I'm pointing at Andy because EIP has funded them, but and they've really distinguished themselves on that front. So how are you thinking about the software side?
Well, I think that being located in Boulder is a huge advantage in terms of being proximate to NREL. There's a wind site in Boulder, and there's a lot of opportunities to look at modeling and things like that. But I would also add that our technology is one of the only technologies that can hit that sub 5 cents per kilowatt hour LCOS, and that buys us a lot of room to not need to deploy optimally and get it right the first time. I think a lot of people are focusing on software because that's the only way to make the economics work. And in our case, we can get to market and quickly and get a product out there that can provide value without having to get to 100% utilization or optimization off the bat.
Thanks.
So getting to market, you know, what does that market look like as you start to scale? And I'm asking this because are you selling a solution that you'd show up and deliver, or is it a service, or what's maintenance look like on your solution or your formulation that I'm sure it has to be maintained? What does that full sort of business model look like when it's functioning?
Yeah, I think that's something that as we scale, those kinds of things will evolve and change, and we'll have to somewhat discover some of that. Based on vanadium flow batteries, I think there's a lot of compelling arguments to say that we're going to not have significant O&M beyond what is used for other energy storage technologies like lithium. One thing to note, even though we have pumped liquids flowing through, things like lithium technologies do also often have liquids in terms of coolant. So the things that wear out in a flow battery are things like the pumps eventually, some of the plumbing and sensors. Those are all things that we can replace iteratively. We don't have to replace the entire battery. So that's I think, a huge advantage. In terms of getting to market, that's something that I've thought a lot about. I think Walter Isaacson's book on Elon Musk is really informative because it made me realize and reflect on the fact that I don't think a single electric vehicle has been profitable for a company that wasn't built in a gigafactory. And what that means is that until we can get to large volume manufacturing, everything is going to be a losing product for us in terms of money. So what that I think means, and what I think that the opportunity that others haven't taken advantage of, is that early pilot systems need to be marketing tools. We need to use any deployment up until roughly 1,000 units to get more customers on board. And I think that deploying things, for example, with a utility, oftentimes, you know, I've been to these ribbon cutting events, and it's just like, look at our big box, and you can't really tell what's going on. I think there's opportunities, for example, with EV charging, where if you had people actually able to directly hands-on use the battery to charge a vehicle, for example, that goes a long way in terms of buying engagement and selling a product. So I think there's a lot of opportunities there in getting to market, but it is a huge challenge, and it's going to be pretty capital intensive.
Michael, thanks for being with us. I'm going to do the last one here. The iron and chromium part of this technology, that seems particularly interesting in light of the world's concern about energy security and where are you getting stuff and how easy is it to ultimately build. Could you just comment on those two inputs and why it is a significant advantage for you?
Yeah, so chromium is used, I think, at least 10% or more of stainless steel. So it's a massive thing. I think the annual production of chromium would give us 10 terawatt hours if it all went into our batteries. So there's plenty of chromium, plenty of iron. And I would say one thing that going into the technicals a little bit, using a chelating agent, sort of our secret sauce here is that these organic materials bind metals very, very strongly. And what that means is that rather than having to rely on highly pure, highly refined metals, we can take crude chromium ores and things like that and use these organic binding agents to pull it out of the mineral directly without any kind of waste involved, and selectively doing that without having to deal with pre-purification of those materials. And that goes a long way. There's companies that, for example, are looking at iron-based technologies exclusively, but iron is cheap, but there's a lot of different grades of iron. So having to deal with highly pure materials is can ruin your sort of cost advantages from the raw materials perspective.
Mike, thank you very much. It's been great to have you here. Let's give him a round of applause. Very helpful. And if you'd like to learn more about Ortoro's flow battery solution, Mike is here and would love to visit with you. Let me introduce our fourth pitch. It comes from Pulsenics, based in Toronto. Pulsenics helps clients measure performance of electrochemical systems, such as batteries, fuel cells, or electrolyzers, using a hardware and software system that employs electrical pulses for fast, high-resolution, and non-invasive testing. Here's Miriam Awara, founder and COO, to tell you more.
Hi, my name is Miriam, and I'm co-founder at Pulsenics. And what we do at Pulsenics is we measure the performance of batteries rapidly and in real time. It's no surprise that we live in the age of the gigafactory. Battery production pipelines are growing at an unprecedented rate to enable the electrification of both industry and mobility. But the challenge remains that existing methods for evaluating the performance of batteries are simply inadequate. They are lengthy, they are expensive, and they are inconclusive. And that leads the battery manufacturer to oversizing assets in order to de-risk performance in the field. But that's an additional price tag of more than $400 million in annual costs for every gigafactory being built. But the battery acts like a black box, so it's incredibly difficult to understand what's happening inside of the battery without destructing it. And that's where Pulsenics comes in. Pulsenics hardware is able to connect to any battery and injects the battery with electrical pulses that don't disrupt normal operations, but that are able to extract critical indicators of performance from within the battery. So effectively, we're able to perform both rapid and real-time battery diagnostics in a non-invasive way. Our target market is the original equipment manufacturer, or the OEM, of the battery. And OEMs are tasked with designing, developing, scaling up, manufacturing, and assuring the performance of batteries for ongoing operations. So we work with the OEM across the entire value chain, starting from the beachhead application of research and development and all the way to the mass market application for ongoing asset management. We've already demonstrated more than 30% faster go-to-market through accelerated R&D timelines for our OEM clients in our beachhead application. And by working with our beachhead market, we've been able to close factory deals for end-of-line quality assurance using the Pulsenics equipment. For our growth market, we're able to demonstrate more than 99.8% faster performance assurance while making sure that every battery cell is comprehensively evaluated in a rapid and reliable fashion. Our hardware is both patented and protected in key geographies where we do business. And we're a team that's been working together for the past 5 years to realize our mission. We've previously built our own companies, and also we've scaled company operations for different startups. We're so lucky that we're also supported by an advisory board that have previously taken electrochemical technology companies public, but that also have extensive expertise in business operations and in the field of electrochemistry from a scientific and academic perspective. What's next for us is scale up. Primarily, we're looking at how do we scale up our manufacturing so we can meet our growth demands on a global scale. And We're looking to expand our go-to-market for end-of-line quality assurance of batteries in our growth application. Thank you so much for your time, and I'm looking forward to answering any questions that you may have for me. Again, my name is Miriam, and we're Pulsenics.
Welcome, Miriam. It's great to have you here.
Thank you so much, Dale.
Awesome. Welcome. Exciting to hear what you're up to. I'm going to say something really obvious at the start. Battery management is a competitive space, right? I know you're living that reality. So I'm really interested in, Miriam, and how you're thinking about the input, the feedback you're getting from your customers on how your solution is differentiated. This is a two-part question. And you mentioned your team. I'm interested in what you think about your team and how they're connecting with the customer and your confidence and that you're turning that into a differentiated product offering in the market.
Well, that's a great question. So I'll answer the first question, which is battery management is a very competitive space, and that's for good reason. It's because performance management of batteries is incredibly complex. It's a very expensive process. And currently, battery performance management is one of the main challenges that are not being talked about enough. So with Pulsenics, what we're able to do is extract a new set of data from an industrial battery. This data is called impedance data. And what that data tells you is how well is the battery going to be able to do chemistry. This data has been used for decades by battery scientists, but just in a lab or academic setting. And we're the first ones to bring this spectroscopy capability to the industrial scale. So what that means is we can be an input into battery management systems worldwide to enable a much more accurate state of health estimation for the battery. And in fact, we've been able to demonstrate that with a project that we have where we've been able to increase the accuracy of state of health estimations by more than 40%. So I would say we're an input that enables better battery management, but we don't develop battery management ourselves. And then the second part of the question is the team. So my co-founders and I have been working together since the end of 2019. And within the first 8 months of working together, we actually went to market with our first product. And then since then, we've been operational in 10 countries around the world with our beachhead market. So in terms of go-to-market, this is a big focus of ours. And at the same time, we've scaled up our technology by 10 times. So I would say that I'm incredibly lucky to work with my team. We're 20 people currently based out of Canada. And yeah.
Hi, Miriam. I like the progression you show on the markets from the beachhead in R&D to then quality assurance during manufacturing to then monitoring in use batteries. Tell us about the adaptations that may need to be made to the product to actually move, especially into that later market and actually monitoring in use systems. And is there a lot of new technology that needs to be developed for that, or help us understand how you would ultimately get to that end biggest market?
That's a great question, because the way that we currently go to market is that we are a plug-and-play solution. So we have a hardware and a data platform, and we're able to connect to any electrochemical system, including batteries, fuel cells, electrolyzers, different form factors, different chemistries. And we use the exact same mechanism to extract information from within those industrial assets. However, we do care about the power level of the system. So what that would mean is further scale up of the technology to be able to work with ongoing asset management. But the most important really is the certification side of things. So just doing enough demonstrations on the longer term to be a trusted partner to go out into the field. So that is something that we're working on currently.
Thanks.
So as you think through that, is the product or the solution, is it something that's installed at manufacturing and then used over time, or is that the bigger market, or is it aftermarket installed on existing systems? Because I hear the QA/QC part of that. We do a lot of that at Halliburton. So I'm trying to imagine QA/QC on manufactured batteries, or is it something that moves through the life of the battery with the battery? Help me understand that.
So that is a great question, because we learn by doing, and so we actually are currently going to market in gigafactories, where we are the end-of-line quality assurance solution for batteries and electrolyzers. And our value proposition there is that we are a rapid measure of performance, and we're a very sensitive measure of performance. So we create something like a report card for every battery that goes out into the field. So what we're hearing from our OEM clients is we want to take out the Pulsenics hardware into the field as well, so that we can continue to collect data on the battery. So we're seeing that as a market trend. However, I will say you can also retroactively connect the Pulsenics equipment on a battery that's already been installed. So it is not necessary for you to get installed in a factory.
Yeah, Miriam, just one quick question. This market, so let's say I'm a battery manufacturer. I assume what I'm looking for is, in my provider of this service, is someone who's very independent. It's almost like an audit function that knows the standards. Could you talk about just the customer and how they're choosing either you or your competitors from a differentiation standpoint? And then how, if you were a HAL Labs company, might that help you win some more customers because of the unique nature of this like almost audit function where you want the best to tell you, is your battery as good as you think it is? That's a 9-part question, Miriam, I'm sorry. The first part is really just how does the customer making the choice, and then the independent nature of the service. Like if you did a whole bunch of other things, you probably need to stay just in this vertical to be really highly effective at your business.
So every single OEM client that we work with always asks to do a trial. So in the beginning, a few years ago, I thought, oh, they're just trialing us because we're a startup. But I actually quickly realized that every company has allotted a fund just for doing POCs or pilots for new technologies. So we've actually integrated that into our go-to-market. So every single go-to-market endeavor is a 1-week trial. 1 week is enough for them to collect data on their assets and generate insights and be able to determine if the Pulsenics equipment is going to give them value on a business side, but also on the technology reliability side. But every single OEM also does their research on any other potential competitors out there. So our differentiator is we're the only inline diagnostic solution that uses spectroscopy to measure electrochemical performance. So because they're so familiar with the type of data that we can provide to them, but they're familiar with collecting it in a lab setting for their small-scale batteries, they know what to do with the data once they collect it on the big scale. And this is why it's an easier sell once you demonstrate that you can actually perform spectroscopy on the big scale. In terms of why we applied to Halliburton Labs, what we think the aspect of being involved with Halliburton Labs, first, of course, is support on the operational scale-up, the ability to actually manufacture and service equipment to different OEMs around the world. But the second really is that demonstration aspect for ongoing asset management for stationary energy storage systems. So this is a key reason why we're here.
We're going to have to leave it here for now. Miriam, thank you so much for being with us today.
Thank you so much, Dale. Thank you guys so much for having me.
Great job. It's been great to have you. Okay, next up, we have a 15-minute break. So this is a great time for networking, meeting some of the finalists. Don't leave. We've got 5 more great pitches coming up after the 15-minute break. See you then. Welcome back. I will invite the in-person audience in here to please wind up your discussions and have a seat. We've still got 5 more great pitches. We've still got 5 more great pitches upcoming. Really appreciate the great audience and really the enthusiasm from some awesome founders. We got more coming up. Our 5th pitch comes from San Jose-based Solactron. The company has developed a new thin film solar technology to improve panel efficiency and manufacturing throughput. We've got Jihad Abushama and David Palm to tell you more about it.
Hi everyone, my name is Jihad Abushama. I'm the founder and CEO of Solactron, a Silicon Valley-based company focusing on leading solar PV innovation, a tunable thin film 2.0 chalcopyrite chemistry, which enables high-performance, low-cost, durable, and disruptive solar PV product offerings. Our vision is to become a world-leading solar panel manufacturer with greater than 34% ultra-high efficiency panel conversion efficiencies. The demand for solar PV is enormous and growing. The current total global solar PV installed power is about 1.2 terawatt and projected to reach about 5.5 terawatt, greater than 1 trillion in module sales by year 2030. Our gigawatt-scale solar PV manufacturing will tap into outsized return on investment. The problem with conventional solar PV, limited solar conversion efficiency, typically less than 22%, profit margins are low, manufacturing processes and supply chain are complex, reliance on single global exporter. Our thin film 2.0 offers the following advantages: greater than 34% projected conversion efficiency, greater than 2x profit margins, simplified manufacturing process, whole panel is manufactured in a single factory, more controlled supply chain, co-locate manufacturing with demand. Solactron's durable product roadmap. Our first product to be offered is TF Next Gen module with about 2.3 by 1.2 meter in size, greater than 25% target power conversion efficiency. The second product offering is TF Ultra module, ultra high efficiency thin film on thin film tandem, including the perovskite material, greater than 34% target power conversion efficiency. Our thin film 2.0 technology has the following advantages: 3 patents granted. We invented manufacturing technology, including process and hardware. The cycle time reduced from hours to minutes, which results in greater than 10x throughput increase, greater than 5x capex reduction, no metallic grids as is the case in silicon, which makes our panels aesthetically pleasing. Solactron's thin film 2.0 is durable and disruptive compared to other solar PV technologies, including silicon, cadmium telluride, and other thin film technologies. The advantages of our technology are ultra-high efficiency potential, greater than 34%, lowest production cost, differentiated manufacturing technology, a durable thin film on thin film tandem panel, environmentally friendly, profitable at the megawatt scale, superior performance in hot environments. Our technology differentiation unlocks clear market advantages. 50% panel cost reduction as a result of greater than 10x throughput increase, greater than 5x capex reduction, greater than 90% materials utilization. 1/100 semiconductor material used compared to silicon. The thickness of the thin film layer on our panels is about 1.5 micron, as opposed to more than 150 micron in silicon wafers. 80% fewer production steps than crystalline silicon, only for depositions in one factory versus several factories for silicon. Solactron product roadmap. Our first product to be offered is TF Next Gen module, fully manufactured at Solactron with greater than 80 billion in TAM. The next phase is a pilot production followed by commercial production. TF Ultra module, fully manufactured at Solactron, greater than 80 billion in TAM. The next phase is pilot production followed by commercial production, and the 2 product phases are separated by 1 year. 1 year. We already manufacture a demo scale panel ready to scale to full-size product targeting hot environments, CNA through distributors. Our team is composed of world-class leaders and experts. I am the founder and CEO of Solactron with PhD in applied physics from Colorado School of Mines and NREL, more than 25 years of experience in R&D, multiple granted patents, achieved breakthroughs in tandem solar cells and also single junction solar PV cells. David Palm, our lead engineer, PhD from Stanford University, Rarib Kairat, PhD in electrical engineering, and he is the former Vice President of Business at First Solar, Saudi Arabia. Thank you everyone for listening.
And it's our pleasure to welcome David Palm, lead engineer at Solactron. Welcome, David.
Thank you. Very happy to be here.
Hi, David. I think I get to lead off this time. Great to see you. Question, I was trying to look at the product roadmap slide, but didn't sort of absorb it quickly enough. Tell us about your current manufacturing capabilities today in terms of, output, total, where do you stand with your, I guess, is it a pilot manufacturing? And then help us think about your plan to scale that up.
Sure thing, yes. Currently at our fab in San Jose, we are producing demo scale panels. So we bring a sheet of glass into the facility, and within a few hours, we have a full operational panel out of that fab that we have there, which is a big advantage over other types of solar panels where it requires multiple factories and kind of very complex supply chains to piece it all together. The next step for us is to build the full-size product with pilot scale equipment. We're currently raising our Series A to bring that effort about, and then from that point, we anticipate kind of a 18 to 24 months from that point, we'll be able to move to commercialization of that full-size product.
So today, kilowatt per year production capability is what? And then with your first financing, that'll take you to what?
Sure. So right now with our demo scale product, we are focused mostly on the process improvement and developing our manufacturing technology. With the pilot plant that we're currently planning and raising to build, that will be a up to 5 megawatt facility for that full-size product. And then the first commercial facility will be a 100 megawatt facility following on from that. And we project that we'll be kind of immediately profitable at that point with our manufacturing breakthroughs to give us the cost competitiveness at that scale.
Great, thanks.
Yep.
So as you develop the film, the question I have is stability of the process to make it. And the one I'm familiar with, or I can't even pronounce, perovskites. So perovskites, I guess, don't last long in the environment. So my question would be, your process, give me a sense of stability as you go through that.
Definitely, it's an important question. And one of the real founding strengths of the chalcopyrite material system, that it is durable. There are actually solar panels in the market today that have 25-year warranties based on a similar chemistry. So we don't face these same challenges facing other thin film solar manufacturers where they're struggling to get to kind of months and years of durability. Our material is rock stable and it will hit those 25-year durability targets with no problem.
So this is great. Thanks so much for being here. One question I had is on the manufacturing competitiveness and cost competitiveness. I think we're all used to, in the US, you can come up with a better way to, new technology, but it's often very difficult to have manufacturing cost competitiveness. Can you just elaborate a little bit on that and why you have confidence there?
Definitely. So what we've done is we've taken a very holistic approach to improving the manufacturing of the panel. Yes, we have this novel chemistry that allows us to achieve high efficiencies, but from the very moment I joined the company, we've been focused on the manufacturing and scalability. And what we've been able to do is increase the throughput of our process 10x compared to the competition, which allows us to bring the CapEx costs down by 5x in our manufacturing. And this results in an overall production cost of the solar panel that's 1/2 of the current competitors in the market. And this is comparing against those major global producers. So we think with that cost competitiveness edge, based on these advantages in manufacturing and the fact that thin film solar just involves less materials in general than other types of solar production, gives us the advantage to be immediately competitive from the megawatt scale. We don't need to immediately be at the gigawatt scale, even though that's our goal, to be cost competitive.
Hi, thanks for being here. I heard you say you were putting it onto glass as a thin film. In your process, you're scaling up your manufacturing, have you thought about how you're going to do your art coating? Are there any temperature restrictions on how you do that? So anti-reflective coating on that to get it to a full product?
Sure. Yeah, we have thought about the anti-reflective coating. There are a number of different ways to do that industry. I think there are some pretty low-cost methods like sol gel processing that end up with a really nice ARC coating on the glass at the top sheet.
So is temperature an issue in your process of manufacturing?
No, the temperature for that anti-reflective coating won't be an issue. The processing temperatures for that are actually lower than the preceding steps in our deposition process. So we know the glass can handle what we do to it, and then the ARC coating is actually easier on it than the previous steps. Yeah.
Thanks, Dave. I'm interested, so you're talking about profitability at the point of commercial scale up in a really sort of challenging margin business. So I'm interested in, you've chosen the Middle East and US as your target markets. How are you thinking about access to raw materials, the price risk there, and waste management as relates to your choice of those two markets?
Certainly. Yes, we have identified large-scale material vendors in the North American market for supplying the high-purity materials that we need. And so we've really found that there is the availability of these particular materials in the North American market specifically. And another thing that we've always focused on from the get-go is high material utilization, so that we actually utilize greater than 90% of the raw material ends up in the functional final panel, which is a big advantage of some other approaches that are out there. And then also with our connections through large industrial partners in the Middle East, we have access to those global supply chains for pulling in the materials that we need in that segment as well.
Dale gave me the nod to ask one more question. Intellectual property and freedom to operate. I appreciate you have 3 patents, but thin film solar is a crowded IP space. Have you done a freedom to operate, and what's your outlook on that?
Yeah, we've done the due diligence, and we're convinced that our 3 granted patents protect this manufacturing, both hardware and process approach, that it gives us kind of the moat to pursue and grow this approach using this manufacturing hardware that no one else has access to. We've invented it, we've developed it in-house, and we're excited to scale it.
David, thank you so much. It's been great to have you here today.
Thank you all. Appreciate it.
Of course, if you'd like to learn more about Solactron, David is here and would love to meet you. Pitch number 6 comes from a company called Clean02 based in Calgary. Clean02 has developed a carbon capture solution for commercial building boiler systems. The solution valorizes emissions by converting potassium hydroxide and CO2 into potassium carbonate that can be sold for revenue. The heat generated by the mineralization reaction is fed back into the boiler to reduce energy input to maintain temperature. Here is Jason Cardiff, founder and CEO, to tell you more.
Clean02 Carbon Capture Technologies is a global leader in microscale carbon capture solutions. Our mission is to sequester carbon emissions within environmentally friendly products, accelerating the transition to a circular lifestyle. We have developed a patented microscale carbon capture solution for natural gas appliances called CarbonX technology. Our technology has been operational since 2017. The technology has a one-time lease payment and installation cost, with no ongoing cost to the owner, and has a return on investment of approximately 5 to 7 years. We currently have 40 CarbonX units deployed, with over 30 units in our current production queue. Did you know that 20% of emissions in Canada, 12% in the United States, and 7% of global emissions come from heating appliances? Our CarbonX technology has the potential to capture a 2.5% market share, which equates to approximately 75,000 buildings. Our strategy for developing this market involves collaborating with gas utilities to introduce our technology and establish North American market hubs. Let's talk about how the system works. We'll need to start with a heating appliance in operation, like a Patterson-Kelly boiler shown here. However, it's essential to note that the CarbonX system is designed to work with any natural gas-fired heating appliance. Appropriate-sized boilers are typically supplied with at least 240,000 BTUs of natural gas and require venting to atmosphere. This boiler will operate by taking in cold process water, heating it up, and then supplying hot process water to the building. This operation is efficient, but not without its environmental cost, as it results in the production of waste heat and greenhouse gas emissions. This is where the CarbonX unit comes into play. The CarbonX is about the size of 2 upright refrigerators and should be positioned within 30 feet of the heating appliance's venting outlet. This proximity is crucial for the CarbonX unit to function effectively. The CarbonX unit directs a portion of the flue gas emitted by the heating appliance into a reaction chamber within the system. The CarbonX unit then converts the carbon dioxide into carbonates, and the waste heat is effectively recovered, meaning less waste heat and less carbon emissions. This process repurposes the recovered waste heat to reduce the building's overall energy needs, and the carbonates are collected for use in various industries. This can include soaps, detergents, commercial cleaners, textiles, and fertilizers. We refer to this as urban mining, a concept that redefines waste as an untapped resource. The CarbonX system is more than a piece of equipment. It's a new perspective on resource utilization and environmental responsibility. The impact of our version 4 technology could see a reduction of emissions by 50% on average. This next-generation technology has a streamlined modular design and applies to all natural gas heating appliances. It also produces 4 times the amount of carbonate and has enhanced operational and logistical performances. Keynote 2 has partnerships with natural gas utilities in both the United States and Canada. We also have international natural gas utility partnerships, including with Tokyo Gas, the largest natural gas distributor in Japan. We have manufacturing and distribution partnerships with Patterson-Kelly and Whale McLean in North America and Akayako in Japan. We are currently working with Choice Hotels and Cintas to include captured carbon from Keynote 2 technology in both organizations' products. We have research and development partnerships with the Gas Technologies Institute and Utilizations Technology Development. Both organizations have independently confirmed the impact our technology can have in the commercial heating industry. Our technology has commercial traction and broad consumer appeal, with both the technology and consumer-focused products to help bring tangibility to the carbon capture narrative. We have collaborations and support from both the Canadian and United States governments for green initiatives and investment from Export Development Canada. Thank you for your time.
And via Zoom, we are pleased to welcome Jason Cardiff, CEO of Keynote 2.
Welcome, Jason. Welcome to the event. I hope you can hear us.
I sure can. Thank you very much.
Perfect. We got the game day vibe going today, and it's energizing for us here. Look, a couple of questions. I'm not sure where to start. The first and foremost, from a market standpoint, do you lower cost for customers, or is this a step beyond? I'm trying to understand the economics from a customer standpoint of installing the system. Is this dependent on regulatory requirements in the future, or is this an immediate return for customers?
Yeah, when we initially started developing this business model, we recognized that there needed to be an economic argument in favor of installing these systems. So our experience with our customers is a bit varied, and everybody's drivers a little bit differently, but at the end of the day, economics tend to win. So we usually present it as an economizer, so we're able to lower the amount of natural gas that each building is using. And then, of course, with the act of taking that carbon and converting it into a commodity, and then sharing that revenue with the customer, we end up hastening a pretty quick ROI in that 5 to 7 year payback period. So, not a lot of HVAC equipment can lay that claim. So that it's largely focused on economics, and then reducing greenhouse gas emissions, and providing access to creating a circular economy in the case of hotels is kind of a follow-on advantage by using our system.
Thank you.
Yeah, hey, Jason, it's Maynard. Quick question for you. When you think about, it's a little bit like Jeff's question, you have the excitement on the front end if you own a boiler and you can put in your equipment and make these changes and maybe share in those downstream profits. Do you think the excitement as you market the product, is it more on the soap, detergents, commercial cleaners, textiles, fertilizers? Is it more on that end where that company gets to say, hey, we have captured carbon, and if you buy our product, you can help us, continue this? Or is it more on the front end? Like, as you see marketing the company, where are you going to emphasize your time?
Yeah, at the end of the day, we're a tech company, so we're really excited about version 4 technology and future iterations of our system. We think the excitement lays in the tech, not in the output. However, the carbon capture markets require that tangibility. When you're having these discussions with, large-scale commercial property owners or just the general public, you have to be able to unpack that in a very tangible way. And carbon capture in its nature is kind of a dry, kind of hard to understand topic. But if you can apply that technology and the output that it produces to a tangible good, it really allows us to open up that door and have those discussions around energy literacy and circular economy and carbon reduction and all of those things associated with it. So they're part and parcel, but our primary focus is on the tech, not on the products.
Yeah, hi, George Coyle with Energy Innovation Capital. Thanks for showing. One question I have is, it kind of goes back to that same issue of the percent of CO2 you're capturing off of it, and if they think about it at scale, how does that compare to other costs per ton of CO2 captured? And the other piece of it is you essentially have this distributed mineralization model where the offtake is, and I think about, okay, now you've got to go around and pick all that up and then bring it to some place that can use it. So as you think about that, all of the goes intos and goes out of to be able to both pick up and deliver the minerals, how does that come out on a per ton CO2 by the time you add in all the other pieces?
Sure, yeah. So it's difficult for us to equate a cost per ton simply because we sell the carbonate on a per ton basis. It's actually a profit per ton rather than a cost per ton. So we've had many conversations with both government as well as folks in the industry that are very adept at determining a cost per ton. And I think if we kind of blur the lines a little bit and try to compare industrial processes to determine cost per ton to something at this scale, I think we're in around the $90 per ton. It's also important to point out, like we believe that while it sounds complicated to do the collection cycle, really the logistics involved in doing that is no different than some of the logistics that are already in place. We see some of our partnerships who already have that logistics built in and sort of piggybacking off of what they already have out in the field. A great comparison would be, take a look at the water bottle delivery service. I mean, if you look at the weights, if you look at the scale, if you look at the volume of delivered products that happen in all of these major urban centers, it's really not that much different, other than instead of delivering water or some other product, we're delivering captured carbon in the form of carbonates.
Jason, hi. Paula Gant with GTI. Our team is really excited about the partnership that we've had with you all, demonstrating this in the lab and military bases and in the field with utilities. And also really excited about this as a demonstration of CO2 to value, as you know. Like, it gets people excited thinking about, well, why do we want to capture CO2? What the heck are we going to do with it? Why do we care? So very excited about that. Recognizing you're focused on the technology piece, though. How are you thinking about that tremendous potential to solve this ultimate decarbonization challenge by turning CO2 to value, and how the technology might be applied in other applications outside of boiler systems?
Yeah, without going into detail, and first I must say, I absolutely love GTI. You guys are amazing. The work that Abbas has done at your Illinois branch is nothing short of stellar. So I really appreciate the support we've received from you over the years. It's been an absolute pleasure working with you. But in terms of scaling up, we do have a roadmap. Our ultimate goal is to get to 100% reduction in greenhouse gases. So we've laid out a kind of a stepped approach to reducing emissions from gas-fired appliances, where our current sort of MVP, if you will, our version 3.4s that are commercialized, can do around that 20% reduction in greenhouse gases. Version 4 is around 50% reduction in greenhouse gases. And looking forward, we have other technologies that we intend to develop that will get us to that 100% roadmap. It's also important to recognize that, we're not just going to be making soap. We're not a soap manufacturer. We are a commodity producer, a green commodity producer. And, we're going to drown the world in bars of soap. But we do feel that there is a significant market play for large volumes of potassium carbonate and bicarbonate products to be produced for other industries, most notably the ag sector. I mean, you think about the amount of fertilizer that North America uses for various industries. So there's tons of room for us to be able to grow without being too worried about market saturation from a commodity standpoint. So again, very, very excited about what the future holds for Clean O2.
Hi, Jason. John Glass with RPE. And in my prior life, I was with a gas utility business in the New York area, and I can imagine with Local Law 97, there's a lot of excitement around this. Question for you, which George got at, but I'm not sure I totally heard the answer. Material handling. I want to understand like the nitty gritty of how that really will work to get the potassium hydroxide to the site, the potassium carbonate taken away, and how do you really see that real operational distributed model happening?
Sure. So currently it's a batch fed process on our version 3.4. So we have independent contractors in each of the major municipalities that we're operating doing the collection for us. We license this contract out to them to both look after the equipment as well as do the collection process. As we develop the technology into version 4, we're going to be moving into a canister exchange program where it's a curbside delivery service where the building operator then becomes responsible for doing the collection cycles for these systems. So again, all of the logistics are already in play. We're just tweaking existing logistics to be able to accomplish that. But right now, as it stands, regardless of which municipality we're working in, whether it's Portland or Chicago or Toronto, we work with independent contractors to do the collection cycles. We typically like to leverage the experience with facility management companies who are capable of doing this collection. And then if there's any work required from an HVAC perspective, we hire independent contractors, licensed trades professionals to be able to go in to do that work to keep the building operating smoothly.
Jason, thank you so much for the pitch and the great discussion. It's been a privilege to have Clean O2 here today.
Thank you very much for your time.
And of course, if you'd like to get connected with Jason, he'd love to hear from you, and we can help you get connected if you'd like to learn more. Next, we're actually going to keep it in Calgary with a quick update from another Halliburton Labs participant company that joined following our finalist pitch day last September. Ortoro Energy is developing liquid organic hydrogen carrier storage technology. Unlike conventional methods, the storage technology provides a high-density hydrogen storage medium without the need for cryogenics or high-pressure systems. This improves the safety and efficiency of hydrogen storage while enabling the use of existing fuel infrastructure for transportation, including tanks, transport trucks, and pipeline. Here's CEO Natasha Kostanek to tell you more.
Hi, my name is Natasha Kostanek, and I'm the CEO and co-founder of Ortoro Energy. Ortoro is developing room temperature, room pressure hydrogen storage in a liquid organic hydrogen carrier. We take hydrogen gas and make it as easy to transport as diesel or gasoline using existing infrastructure of tanks, trucks, pipelines, and rail cars. So hydrogen is a growing market. We're really excited about hydrogen like a lot of people, but most people are focused on hydrogen storage or end-use technologies. And we think the real gap is hydrogen storage and transportation. That's the real bottleneck to broader hydrogen use. Hydrogen is typically stored at very high pressures or very cold temperatures, and these require specialized equipment, complex logistics, and increased costs. Our novel LOHC technology, or liquid organic hydrogen carriers, enable us to store and manage hydrogen no differently than diesel or gasoline. We make hydrogen simple. Our technology works by taking hydrogen gas and chemically binding it to a carrier oil for that room temperature, room pressure liquid. And when it's bound to the oil, it's a jerry can solution. Anywhere diesel can go, our liquid can go, including tanks, trucks, rail cars, and pipelines. And when you need the hydrogen again, we can chemically unbind it from the carrier oil, and the carrier oil is returned and recycled over and over again as a carrier fluid. What's best about our technology compared to our competitors is when we release the hydrogen from the carrier oil, it's fuel cell grade, go directly into fuel cells and does not need any purifications. So we had a really exciting 2023. We grew our team from 3 people to 10 people and grew our technology in size over 30 times larger. And we're getting ready to deploy our first pilot with a local gas utility here in Canada for 30 kilogram a day storage and release of hydrogen. And we're going to continue to scale that. Next year, we're going to be at 300 kilograms per day. And we have some early commercial opportunities we're exploring in 2026 for 3 tons a day, and we'll continue to scale beyond that. So we're currently based in Calgary, Alberta, but we plan to expand to Houston later this year, growing our team and hiring more people to work out of our Houston base for doing scale-up and manufacturing. And we're going to be doing that with the help of Halliburton, leveraging their resources and their facilities. We're really excited to have that opportunity. It's really game-changing for us to have that extra support. If you want to learn more about Ayrton's LOHC technology or talk about your upcoming hydrogen projects and how we can help you store and manage your hydrogen, please feel free to reach out. You can email me or you can contact us through our website. I'll also be attending and presenting next week at Zero Week at the Agora conference on Wednesday afternoon. Please come find me and we'll connect.
Thank you, Natasha. As she mentioned, we've enjoyed the relationship of working together. She will be in Houston next week for CIRA, and we're looking forward to seeing her again and are happy to help you get connected if you'd like to learn more about Ayrton's journey. The next pitch comes to us from Thiozen. The company has developed a hydrogen production method that uses sour gas waste streams found throughout the energy supply chain using a patented chemical process. The company is based in Pasadena, California. Here is co-founder and CEO Ryan Gillis.
Hello, my name is Ryan Gillis. I'm an MIT-trained chemical engineer, and we need to talk about hydrogen. I've noticed there's a lot of misunderstandings about hydrogen in the market today. First, hydrogen's not a new commodity. We've been making it in large volumes for at least the last 100 years. The problem is that currently the only economic production method strips hydrogen off of a hydrocarbon molecule. This predictably leaves behind carbon, and quite a lot of it, in fact, to the tune of hundreds of millions of tons per year, some 2% of all global greenhouse gas emissions. This is a problem that's not really easily avoided. One approach to doing that would be to use raw water electrolysis as an alternative production method, but it turns out this sort of just turns the problems on its head. Electrolysis is in fact an even older technology than hydrocarbon reforming, and in fact, if you put in enough green electrons, you will get out green hydrogen. The problem is you need quite a lot of green electrons, too many, in fact, I think, for cost-sensitive firms to be able to adopt to the higher prices that these would cause. And if we look at who's buying the hydrogen, we see it's almost exclusively these cost-sensitive firms, people like oil refining or petrochemicals, agriculture in the form of fertilizer production, methanol manufacturing, things like this, industries that can't really handle price shocks to one of their most key inputs. And if we think about all of the sort of commonly referenced hydrogen markets, things like, for light duty transit or even long haul trucking, steel manufacturing, consumer use. I think, over the next decade, it's our belief that these are all going to be rounding errors or continue to be rounding errors compared to the real consumers of hydrogen, which are, again, these core heavy industry activities. And they're really who we should focus on if we're trying to have an impact with hydrogen. So I sat as a young idealistic student, over in Cambridge at MIT, trying to think, well, how can we get around these problems? And eventually I came to the conclusion that you really can't. Carbon intensity is fundamental to the extraction of hydrogen from hydrocarbons. And water, nature loves water. And the costs associated with extracting hydrogen from water are always going to be high. And so I thought, we've just got to look somewhere else. So I pulled out my periodic table and with a Sharpie started Xing things out. Eventually, I landed on sulfur. And despite many, many problems with sulfur, it checks a lot of the most important boxes, the most important of which is scale. Right? Sulfur is processed at a globally significant scale such that if we're able to extract hydrogen from a sulfur-containing molecule, notably hydrogen sulfide, then it will impact, it has enough scale to impact the global markets. But also it's thermodynamically less stable than, say, comparison to water. And in fact, this processing of hydrogen sulfide is pretty geographically close to a lot of hydrogen demand. So it has a lot of good properties. And I spent years trying to figure out what is in fact the best way that we can get hydrogen from hydrogen sulfide. And eventually I discovered something. I found a thermochemical process where I could leverage the oxidation of hydrogen sulfide to extract hydrogen gas from that molecule. We went to the markets and they knew just what to do with this. The natural gas producer said, great, we would love to be able to turn this liability of hydrogen sulfide content into an asset in the form of hydrogen, particularly a very popular asset nowadays. And refineries was even better, right? So I'd say it involved a step-up change in their molecule efficiency around these hydrodesulfurization units. Currently, they pay in a lot of hydrogen to these units to be able to remove sulfur content from these hydrocarbon crudes. And so to be able to draw a circle around that and recover that hydrogen so we don't continually have to pay in this energy and material cost represents a big improvement in how things are done. So if I were you, I think I'd have one question at this point. Is this real? Right? I mean, theory and good ideas are nice, but usually they don't pan out for one reason or the other. I'm happy to announce that this is real. We have built a commercial pilot of this. We're out in an actual production site in the Permian Basin in West Texas. We're connected straight out of the ground, raw natural gas, 1.5% hydrogen sulfide content, and the technology is working. We're producing the hydrogen sulfide, we're removing that, we're producing the hydrogen, we're removing the hydrogen sulfide. The technology is working as we expect it to. And this gives us confidence that as we scale up, we're going to be able to hit our marks around these key energy and cost figures. So with that, of course, with this exciting technology, we have plenty of interested partners willing to cite. One notable one, which will be our next demonstration, is in Alberta at a very large natural gas processing site in Alberta in the Whibley region. And from there, of course, we'll expand and one by one, replace this hydrocarbon reforming as the principal method of hydrogen production for these commodity chemical manufacturers. If you'd like to be a part of this, please reach out either as an investor or as a potential site partner. Thank you.
We're excited to welcome Ryan Gillis. Glad you're here.
Yeah, happy to be here. I think it's been a while since I've been in Louisiana. And it's Louisiana, just for one quick digression, Louisiana is actually very interesting to us because quite a lot of hydrogen use in Louisiana and quite a lot of sulfur processing. Before oil and gas even took over sulfur processing, Louisiana was sort of the world center of frash mining, which was sort of the way, say 1900 to 1960s way that we got the sulfur. So we think about Louisiana a lot, but don't necessarily have opportunities to come down here too much. So we're really grateful for this event to bring us here.
Well, Ryan, again, welcome. This is really fun, and it's cool to see something where you're creating value from a waste product. I guess my question is a little bit about the sale. If you come into me with your technology, we all know that getting people to adopt technology is a little bit hard anyway. Yeah. With H2S, there's going to be this like, oh, God, this is such a dangerous and a annoying thing. I'm going to, seems like, have more reluctance to mess around with it. tell me about that sale, and also add in for me, I guess the other problem is, that's cool when you make it hydrogen, but I got to make sure I've got ways to use the hydrogen there. So how important is that second piece as well to the sale?
Really important. I think, you highlight the difficulty of sales into these conservative industries using, tricky materials and tricky process streams. I don't know if there's any silver bullet answer to that. It's hard, right? You have to show demonstrations. You have to go onto the site, show that the technology works, and do scale up really with each customer you're working with, right? So there's no, I don't know if there's any sort of silver bullet. And the second part of your question was, remind me?
Well, I got to use the hydrogen. So
Yes.
how important is that to the discussion?
So this is great, and we're excited to see work in hydrogen transport and compression and storage. But I think right now it's not there, right? And so in general, we look at sort of our internal philosophy is that you need to be using the hydrogen on site because if you're going to spend if the hydrogen itself costs say 80 cents a kilogram to make or $1 a kilogram to make. Usually it doesn't make sense to spend $1.50 or $2 moving it, even 100 miles or 50 miles. So typically we look to site these installations. I would say the ones we've done to date, we site the installations at a location that has a very proximal use for this hydrogen. So in the downstream, it's obvious, right? It's sort of, they're using, they're the main consumers of hydrogen actually today in the United States. Especially around these hydrodesulfurization units. In the natural gas markets, it's a little less obvious, right? I think the customer we're working with in Canada is using it to decarbonize some of their sort of their generating and production assets up there. But you have to work a little bit harder. And certainly, I guess I would, to answer your question directly, it's very important to figure out a use for hydrogen because in most hydrogen projects, you need to use the hydrogen as hydrogen. I think, and Andy said this earlier today. If you're using the hydrogen as natural gas or as something else, just a combustion fuel, it's harder to make the economics work, right? You need to figure out a use for this hydrogen as hydrogen.
Yeah. Hey, good to see you. Very exciting. When you think about the scale, I mean, you take the H2S, go through your process, but in terms of the operator, he's trying to remove the H2S from his gas stream. And so you're downstream of that. You need the H2S already separated. And so I'm trying to understand, would this end up being applied in the field or where they've gathered? Help me understand your economics at kind of the collection stage or at the refinery stage and how your economics change on the scale.
Yeah, absolutely. So I think this highlights a sort of one of the values that's maybe not, we didn't highlight necessarily in the pitch. Note that what we're taking in our pilot is raw natural gas coming right off of a heater treater. Raw associated natural gas, mostly methane, ethane, propane with 1.5% hydrogen sulfide. So this technology is not just making the hydrogen from this hydrogen sulfide, we're actually separating out the hydrogen sulfide from the gas. So in essence, we're taking the spot of these amine units. Now we don't do as much on CO2 removal and things like this, but I think it's our view that, for example, where we would sit in a natural gas plant is right upstream of where these amine treaters are right now, sort of after the coalescers to knock out most of the liquids and solids, but before we do much other processing, because again, we would want to take advantage of this technology's natural ability to remove hydrogen sulfide from these process streams. In terms of scale, of course, we benefit a lot from economies of scale. I think we've done quite a bit of techno-economic analysis to think about what are the break-even points or break-even scales of this technology. I think the truth is we got to get to several tons a day of hydrogen sulfide processing before we sort of make this leap, before sort of the capital expenses and the utility expenses are justified by the amount of hydrogen you're producing, right? So that puts us in sort of this mid to larger range natural gas locations and, of course, these downstream sites as well.
So one quick follow-up on that. So since you're taking it out of the natural gas, in terms of, as you think about, obviously you're doing the pilot now, but you need to scale up. So how do you kind of guarantee the reliability? Because obviously for them to sell the natural gas, they have to have it out. So they're either going to be using you or something else. And if you're not replacing it, then you're additive. So do you take out 99.99 type percents, or what's the issue there?
Yeah, that's a good point. And the hydrogen sulfide removal we found to be very efficient. So we go from 1.5% to very low parts per million, well within the sort of pipeline specs for hydrogen sulfide in that pilot unit we have right now. Of course, there's scale up to happen. So it's not a trivial thing to bring a technology from this pilot scale up to 100x, which we're going to do in Canada. So of course we'll have to watch this and we perhaps iterate and think about how that design goes and work with very talented engineering teams to make sure that those product specs remain consistent. But yes, I think we look ourselves as completely replacing that hydrogen sulfide removal and getting the vast. You can never go to absolute zero, but within this very low parts per million type range.
Ryan, welcome to Louisiana. Thanks for giving a props to my hometown of Sulphur in Southwest Louisiana, which we claim was the epicenter of fresh mining back in the day. So thanks everyone for giving me a chance to acknowledge that today. So as I understand this is your process can be used to retrofit refineries that might be using SMR or in other processes, and that might involve some derating of those existing processes. Question for you. And so then how, as a refiner, would I think about the economics of making this investment? I mean, what's in it for me?
Yeah, so it's the question of, if you are using hydrogen and, we supply you with 50% additional amount of hydrogen, what do you do with it? Of course, from our side, we're very, we think a lot about impact. Our goal is really to try and displace a lot of these fossil fuel-based hydrogen production methods. But I guess practically, you supply more hydrogen to a customer, they're going to do what makes the most economic sense for them. And often that's going to be the transformation of, products into higher value products using this hydrogen. So I think, if you talk about the site value proposition, I think it's especially in highly regulated locations where it's hard to bring in additional hydrogen generation assets. Something like ours can displace, of course, these SMR units. It also can provide additional hydrogen to increase the profitability of the unit overall.
Hi, Ryan. As a former Louisianian, I moved here in high school. I was going to flex my local knowledge, but Paula beat me to it. So, drat. One quick question, then if I can do a second one. But does this process qualify for the 45V tax production tax credit?
Yeah, so we do get below this 0.45 kilogram CO2 per kilogram hydrogen production threshold. Of course, to qualify through it, there's a number of mechanisms. The main one is to use this GREET model out of Argonne National Lab. So this technology is not included in the GREET model at this point. We're working with the team to make it into the next iteration or the next few iterations of it. But there is, of course, other methods that you can qualify that we would put these projects in as we had relevant sites in the U.S.
Cool. I have a colleague on the GREET working group, so if that's helpful. Can I ask quickly? How do you treat in your TEA sulfur dioxide that's coming out of the process? Is that a cost, a commodity with a benefit?
We treat it as a cost right now. I think it's a good point, though, because long term, I would suggest that Louisiana's in a pretty good spot because I think sulfur is going to rise in value, right? I think in the 60s and 70s when the environmental regulations came in that required the removal of the vast majority of sulfur from hydrocarbons before their use, suddenly sulfur became the cost of putting sulfur on a train, right? And all these frac mines closed up. But I think over the next 10, 20, 30 years, the demand for sulfur globally is going to continue to rise, right? I mean, people are going to continue to need fertilizers. The need for intensive agriculture is going to increase, which is going to drive up the demand for sulfur, while I think probably the supply of sulfur is going to level off or maybe even slightly decrease. And so I think we see ourselves at a pretty fortunate place. Right now, we treat it as a cost. We say it's going to, in most brownfield implementations, we think about sending it back to the thermal stage of a Klaus and going to elemental sulfur before it's shipped off and this type of thing. And then you have some incidental costs associated with lost steam and such as this. But in long term, I think we see ourselves as being in a really nice position to take advantage of what we see as a long-term rise in sulfur prices and allow us to generate oxidized sulfur products like ammonium thiosulfate or sulfuric acid and things like this. And in fact, actually a few of the projects we're looking at are directly going into this to make things like ammonium thiosulfate. But I'd say the base case we think about is this sulfate or sulfur dioxide is a cost that's gonna go back to elemental sulfur.
Ryan, great job. Thank you for the pitch. Thank you for the great discussion. It's good to have you here.
No, it's a pleasure to be here and good to be in New Orleans.
All right, of course, we've got Ryan here, and if anybody would like to connect with him, he would be delighted to speak with you. Pitch number 8 comes from Adena Power, based in Lewis Center, Ohio. Adena is an energy storage provider using U.S. raw materials and manufacturing to deliver sodium batteries to behind-the-meter commercial and industrial customers and utility markets. The company's patented sodium battery technology is targeted towards unmet storage industry needs for safety, flexible duration, ability to operate in higher ambient temperatures, and lower installed cost. Here is founder and CEO Nathan Cooley to tell you more.
Hi, I'm Nathan Cooley, CEO of Adena Power. I have my co-founder Neil Kidner here with me today. We've worked together for over a decade commercializing clean tech for large corporations. I personally have run climate tech businesses for the last 15 years through all those ups and downs. Adena Power is a once-in-a-career opportunity for us to do something meaningful for ourselves and the planet. We see Halliburton Labs as a catalyst to achieve this vision.
Through years of customer discovery, we've heard again and again that lithium-ion batteries only get us so far. As the EV marketplace continues to expand, utilities do not want to be last in line for batteries. To meet their climate goals, they need non-lithium energy storage solutions. We address this problem with our breakthrough sodium solid-state batteries and systems. Cost-effective, long-duration storage is critical to firming renewable assets at the commercial, industrial, and grid scale.
Previously, I launched a lithium-ion battery safety monitor. This gave us a great understanding of safety's role in energy storage. Adena will use a two-phase go-to-market approach. We will launch a turnkey system for the commercial and industrial market for early revenues and product validation. The CNA market is a stepping stone to sell modules to utilities for grid-scale storage. Ultimately, our goal is to become a boring company selling standard products to large groups of customers.
There's not time to invent a brand new battery chemistry. Early on, we talked to project leaders of GE's Duraform battery. This battery chemistry had excellent performance, but 2 fatal flaws: a tubular cell design and a high nickel content. Leveraging our ceramics expertise has allowed us to innovate beyond to a lower cost, planar cell. We have also an exclusive license allowing us to substitute iron for nickel, thus shrinking the raw materials costs. The result is a differentiating battery technology that combines the energy density and round-trip efficiency of lithium-ion with the safety and lifetime of flow at a cost that pencils. Furthermore, we have a strong IP position that will stop potential followers.
We have an amazing team made up of talented men and women. We also realize that we have to surround ourselves with industry leaders from utilities, manufacturing, and R&D. We see Halliburton Labs as a perfect partner for Adena and have identified 3 main areas to focus. Supply chain, certifications, and product testing will enable us to go further faster.
We have already taken our technology out of the lab. Late last year, we completed a successful building block module test at Ohio State University and have a secure demonstration with Duke Energy later this year. We're currently out raising $3 million of seed funding and in parallel working to secure as much non-dilutive government funding as possible. With seed funding, we'll scale manufacturing and conduct product intent demonstrations that will allow us to convert our $50 million pipeline into purchase orders. Given our path to scale, profits, and the utility market, we're setting up the company as an attractive acquisition target. I've done this before, managing the sale of assets to large corporations that took the technology further, and I know we can do this with Adena Power. Thank you.
Welcome, CEO Nathan Cooley. Great to have you here.
Thank you very much. I'm really looking forward to the next couple minutes talking through Adena Power and what we're trying to bring to market here.
Great, Nathan, glad to have you here. I think you even brought it up in your video. Other people have been out marketing this technology, and so you're kind of saying, I now have this better, you've seen it, but now it's better. Explain what are those key metrics that you're hearing from customers that you're going to be required to get them to now believe that this is going to be the one that's going to be economic for them?
Sure thing. So from our perspective, we realized there wasn't time to start a brand new battery chemistry. That's going to take 20 years to get to market. And honestly, the window's going to close by then. So as we did discovery, we realized that GE had some technology they tried to commercialize in 2010, but it had two big fatal flaws: a really cost-effective membrane and then using nickel. So we looked to revolutionize beyond that and use a planar design, which I've got with me today. And at the same time, we licensed some technology from P&L to get rid of the nickel and bring in iron. Our customers, or our potential customers, they care about cost. They will say that they enjoy safety, they enjoy the long duration, but ultimately, if that project doesn't pencil, they're not going to want to install it. So our guiding principle has been, how do we drive cost out? And making sure that we work with really low-cost raw materials that you can get in rail cars is the best way for us to do that.
So how much capital to get to like $99?
How much capital to get to $99? So for my very good question. What we're doing is we're already setting up a supply industrialization partner, Current Chemicals, up in East Cleveland, Ohio. They have the underutilized assets that we can bring to bear and get us below $100 per kilowatt hour at 5 million parts per year. So a really small amount of parts allows us to come down that cost curve really quickly. Ultimately, our goal is to get to $35 per kilowatt hour. We believe that that's possible within megawatt hours of capacity.
Hi, Nathan. I'm interested in your partnership with Duke Energy. So they're a great example, obviously, of a very large utility, but they're also very forward on understanding things behind the meter with their customers in this next generation of solutions. So how are you leveraging that partnership with Duke to understand the issues around installation and maintenance and waste management and recycling in your phase one of your market build-out?
Sure thing. So Duke Energy is amazing. They have been with us from the beginning. We launched a product called Lion Tamer about 5 years ago. That is mandated on Duke Energy's grid. So we've returned value to them in the past. They want to see what we're going to do in the future. So they've been very instrumental in having us bring technology to bear, help us flesh it out, make sure that it can be that guiding demonstration that allows that first target market, those beachhead markets, to make that buying decision. Our ultimate goal is to get back to the utilities, but understanding that they're not making, they're not going to be the first customer of yours. They make a very pragmatic, cautious buying decision. We want to prove our case at Duke from a demonstration, launch into that C&I marketplace, allows us to get product validation and early revenue, and then we're going to be able to go back to those utilities. But every time I talk to a potential customer and tell them that we're going down to Duke Energy, they go, when can we get that data? We want to see how that works. Those guys are amazing, and if you guys are doing something with them, we want to be a part of that.
Hi, Nathan. As a GE alum, you weren't able to talk about GE Durathon. It became a dirty word, so I think that's what you were referring to. But want to see if you could kind of flesh out the use case for the C&I behind the meter application. What are you talking about in terms of both cost per kilowatt hour, energy, density, power density? How does that look, or maybe put a little bit more meat on those bones?
Sure thing. So from our perspective, getting into that C&I marketplace, we want to go after two beachhead markets, one being fleet EV charging and the other being healthcare resiliency. We see that we've got a great use case in both of those positions with a long duration energy storage device. At the same time, having launched that product, Lion Tamer, we understand just how important safety is and how much that's going to change the landscape in the C&I marketplace, either for insuring or financing or even just project density. That's something that we like to talk to. From a cell perspective, energy density is comparable there to lithium ion. The cycle life was amazing when GE was working with the Durathon technology. We believe by putting new technology in and actually driving that temperature down, it's going to increase the lifetime of our units. But at the same time, what we're going to ultimately be focusing on is how do we drive the cost out of this so that customer, they're not having to make a sacrifice of going, well, I'd really like to use new technology and I'm willing to pay a really big premium for it. That's just not going to happen. So being able to take the cost out, be 30% lower installed cost than lithium ion is what we're driving towards. Getting rid of that HVAC, making sure that we're using sodium and nickel, so really low cost materials, and giving them a form factor that they're already used to is paramount to our potential success.
Are you looking at similar durations to lithium ion, or are you going longer, like beyond 4 hours?
We want to do more of an intraday type of battery. If we can, 4 hours is great, and I think we understand how to monetize that right now. Everybody we talk to knows that we need long duration energy storage to firm up our renewable assets. I know we talked about curtailment earlier today. We're going to be able to get rid of that with longer duration energy storage. So we're targeting that intraday, one up, one down type of solution, because that's where you're going to monetize the most out of that battery.
Wow, I'm listening. Am I on? Yeah, we're listening intently. As you've done some trials, so what's the next step? Sort of walk me through is it a giant step in capital, or is it service, or is it licensing? How do you think about the future? I know it's mired in the challenges of today, but take me to the next step of what's scaling look like. Is it a installation arm? Is it manufacturing? What's all that take?
I love thinking about the future. And when I'm thinking about the future, I want to make sure I have as many options as possible so I don't have any missteps and I'm stuck in one direction. So the future to us, it looks like we're a race car driving down the track and we're changing all the tires at the same time. So we're going out there, we're making sure that we can bring on as many early adopting customers as possible so that when we are into manufacturing, we've already sold out our capacity. From our standpoint, that's paramount. Nobody wants to have the field of dreams, if you build it, they will come type of model. We want to make sure that they're already there and that they're ready to make that buying decision.
So can those happen sort of incrementally then? I mean, this is something that can grow and continue to grow capacity while it grows?
Mm-hmm. Definitely. In fact, I was over at ULL yesterday looking to figure out how we can get a couple deployments on their microgrid. They're a great university that wants to bring early technologies forward faster. They're comfortable being that first early adopter, and they're willing to make a buying decision around that. So from our perspective, we want to gain those customers, show that potential value, and then at the same time, it's all about scale up. I mean, I know we've talked about that earlier. I think Andy mentioned that about scaling manufacturing. It's a very easy place to fall into that manufacturing valley of death. And from our perspective, bringing a group like Current Chemicals online earlier is going to allow us to have somebody that's done that before so that we don't have those missteps. And then frankly, my co-founder and I's experience over the last 15 years here in the clean tech industry, scaling up products, scaling up technologies, licensing those to large corporations, we understand how to take things from that bench scale to lab to pilot to industrialization. And that's what we're going to do with Adena.
Thank you.
Mm-hmm. Yeah, I think my question sort of follows a little on Jeff's, because I noticed you mentioned in the video, you've done a lot of exits, and so you have the experience of how to get out. And then you also mentioned the window you referenced, like there's a window here to go through. How do you think about financing the company as it relates to your strategy? Because it looks like you're going to go hard, you're going to get units in, right? And there's a window and there's an opportunity. Like, how do you've seen a lot of these types of businesses, how are you going to financially engineer your strategy?
I think there's a couple, maybe it's a triad of we need to look for as much non-dilutive government funding as possible. So that's why we make sure we've got a nice large pipeline there. I know that we just recently, or yesterday, there was great news about the hydrogen hubs and how much money's going into that. But you've got the DOE loan office with Jigar Shah and how much he's putting into long duration energy storage. So that's going to be one area that we're going to focus, because if we can bring that capital on, it's very cheap, it's very cost effective, and it allows us to go further faster. The other side of that is making sure that we're working with the venture capital community. That is going to be the catalyst that we need to go that much faster. And then the third side of that is working with our customers. We want to bring early revenue on maybe a little sooner than you would typically see, but that allows us to get that product validation. It also reduces our burn rate so that we can go to that next step. And then finally, making sure that we're not using like a lithium-ion battery manufacturing plan. We're using more of a solid oxide fuel cell play that allows us to use those underutilized assets in the Midwest and potentially down here in the Gulf Coast, where you've got that manufacturing spirit, you've got that culture and the infrastructure, and allows us to have that CapEx light approach to get to pilot, get to industrialization, get to that gigafactory level.
Nathan, thank you so much for the pitch. It's great to have you here. Great job with the discussion. Next, we've got our final Halliburton Labs participant update. We're going to hear from Dustin Angelo, CEO of Novamera, another company, on how they started, the opportunity that they're capturing in the mining industry, and what's coming up next on the capital raising front.
Imagine it's 2019 and I'm sitting in a crowded restaurant at PDAC, a major mining conference in Toronto, and I'm with the chairman of Anaconda Mining. That's the mining company that I was running for about 9 years. And I was excited to tell him about this great idea to spin out this really cool technology that we've been developing. And he immediately grasped the vision that I saw, the multi-billion-dollar opportunity to help mining companies unlock stranded mineral resources. And I remember the look on his face and the 3 words that he said to me: go for it. So shortly after that conversation, we took the technology, we spun it out of Anaconda Mining, and we founded Novamera. And so at Novamera, we've developed hardware and software technologies for surgical mining to help mining companies unlock stranded mineral resources and create new opportunities from untapped small-scale deposits. And our market analysis and database has about 4,000 projects, 700 potential targets worth about $35 billion in revenue. And our technologies lower project risk, require less capital, reduce development time, are eco-friendly, and enable faster permitting. To date, we've successfully done 3 projects, and we have plans for more projects this year, along with a very healthy sales pipeline. We have the potential to do 5 projects in the next 18 to 24 months, and we're raising capital to be able to service those customers. We're seeking a lead investor that is interested in supporting a transformational technology and truly revolutionizing the mining industry. We're really excited at where we are today at Novamera. There's a great opportunity to invest in our company and truly help us get to that next level. If you're interested in learning more about what we're doing, I'm happy to have a chat, so please get in touch. And good luck to the rest of the finalists.
Great to hear from Dustin, a company that we've been working with for a couple years and excited about the progress that Novamera is making. We're happy to get you connected with Dustin. The final pitch comes from Xplorobot, a Houston-based company. Xplorobot is offering a low-cost, easy-to-use solution that enables untrained operators to measure asset-level methane emissions. The solution enables asset owners to detect, repair, and verify compliance to minimize the cost and labor requirements of new regulations in the US and EU. Here's CEO Oleg Mikolaev to tell you more.
Xplorobot is a software company bringing artificial intelligence and computer vision to solve the most critical challenges in the world energy infrastructure. My name is Oleg Mikhailov. I'm the CEO and co-founder of Xplorobot. I have 25 years of experience in the oil and gas industry, ranging from technology development to operating giant oil and gas fields around the world. My co-founder, Richard Clark, is a former chief geophysicist of TGS, the largest seismic contractor in the world, and has 20 years of experience in seismic imaging R&D at British Petroleum. Barbara Miglietti, the graduate of the Harvard School of Design, is responsible for all of our client-facing dashboards, reports, and user interfaces. We're fortunate to have industry veterans on our advisory board, Stephanie Cox, the former president of Schlumberger North America and executive president of Wood, Lamar McKay, the chairman of the board of Apache Corporation and the former CEO of British Petroleum Americas, Alan Thompson, the head of the Boston Consulting Group Global Energy Practice. Methane emission mitigation is a critical task. In the United States, European Union, and Canada recently enacted regulations requiring quarterly inspections of all equipment with handheld devices. It's a noble task, but it puts disproportionate cost burden on the United States independents. The current solution, the infrared OGI camera, costs $120,000 and requires a highly experienced, certified, and expensive inspector to operate it. U.S. independents with 10,000, 5,000, 3,000 wells cannot simply afford OGI camera inspections or permanent sensors. So Xplorobot delivers a solution that enables them to meet the regulatory requirements. Our solution is a complete one-stop shop for meeting the new Code of V, Code of C regulations enacted. We provide a handheld sensor in the field that can be operated by any mechanic or maintenance tech. We provide a seamless data flow into corporate ERPs and compliance databases and the communication infrastructure to provide timely notification to repair crews to mitigate emissions. Our hardware is 10 times cheaper than the incumbent while providing the same accuracy. It can be deployed by anybody. It is already compliant and accepted for meeting the regulations under Subpart W, the greenhouse gas emission reporting required by EPA. Our solution is highly sensitive and provides quantification of the emissions rate. We achieved multiple awards for our technology, and most importantly, we're ranked as the most accurate technology amongst all the technologies tested at the Methane Emissions Technology Evaluation Center at Colorado State University. The important part of our solution is the digital infrastructure. We're delivering digital emissions tags and digital compliance records to enable reporting and analysis of the emissions in the operations. Our reporting is based on a map-based dashboard, and for each site, we provide the ability to access to the equipment and the component level inspection results. First and foremost, providing visualizations of the methane emissions that is required by United States law. Second, we're able to give an actual map of methane concentration on the model of the equipment, thus providing not only the location of the emissions, but also certifying the lack of the emissions of all the components that have been inspected. For simple equipment such as flanges, valves, we're using machine learning and artificial intelligence to create either records of emissions or digital records of compliance. Xplorobot is transitioning from piloting the technology to sustain revenues with multiple clients around the world. We would be honored to work with Halliburton Labs. Halliburton scale and work with clients around the world will advise us on how to grow our operations. Halliburton's experience in manufacturing of oil field services equipment and in providing digital platforms such as Landmark will guide us into how to scale up our operation and help the world meet the methane mitigation needs at a cost and labor efficient manner. Thank you for your attention.
Welcome, Oleg. Excited to have you here.
Well, thank you for the invitation, and it's good to see some old friends that I've known for many years.
Awesome, Oleg. I'm excited about the market opportunity you've identified clearly over the past decade. Operators have made significantly bold commitments to reduce methane emissions, and there's an urgency to do it this decade. So we've seen a lot of technology providers and solutions providers come into the space. So really excited that you've got some testing at METAC at Colorado State. That's really important for operators to be able to evaluate your service. But we know that it's going to be put together with others. Like, it won't be just a silver bullet on its own. And we're going to need to take data off of of what your technology provides and integrate it with other streams of data so operators can make decisions. So how are you thinking about how the data from your systems offload for operators and they put it to use with the data they're getting off of other tools they're going to use? And then in that step before you're handing it off to them, how are you thinking about data privacy?
These are very important items that you identified. So first and foremost, there's a full spectrum of technologies for methane emissions, ranging from space to airplanes to continuous monitoring to handheld that an operator needs to take to the field. The most important thing, no matter what, and please try it, because no matter what technology you use, ultimately it is tightening that bolt. It is replacing that flange, which actually reduces the emission. So no matter what else you use, the handheld is absolutely essential. When the alarm from the canary rings, somebody needs to pick up either a $120,000 OGI camera or our device and go and find where is that leak located. So there's always going to be a range of technologies. Now, our flow of data, so we accumulate methane measurements 10 times a second, high-resolution photographs 5 times a second. We download them at the end of the inspection day from the sensor into the edge computer and do processing at the edge. We do have infrastructure for processing in the cloud if a customer prefers that. But we have APIs into systems of records of every corporate client. Because right now, pretty much everybody, except for smaller independents, have some sort of emission reporting infrastructure. So you tell us what the data package is, and we will provide it to you. So we absolutely designed the system from the very beginning, keeping in mind that we will be data providers. For smaller independents that don't have these ERPs, we can provide ours. But remember that, like, honestly, our most favorite client is the US independent that says, Oleg, I can't afford a canary. I can't afford an OGI camera. So we will provide our systems to them, and most likely they just naturally will not have a parameter sensing because it's just cost prohibitive. Oh, this is mine. By the way, if you want to try this, since you are,
I have this. Did I turn this on? Or?
Yeah, you turn this on.
How do I turn it?
Shine the laser at the cap of the methane.
Ah, look at that.
And it will
start.
Maybe. Oh, you need to start. That's as difficult as it gets to detect methane.
So my question is on other applications. It looks like you're really focused, upstream at the wellhead. So, but with 1 gram, was it 1 gram per hour?
1 gram per hour.
sensitivity?
Yep.
I mean, that lets you go downstream, fugitive, leak detection, gas compressor stations, even in distribution networks. So are you looking at those downstream applications?
So definitely, we work with upstream customers. We work with midstream customers. We work with power customers. We work with landfills. So it's anywhere you have to monitor methane, you can use our device. And again, the most important element, just as you on the panel just are trying the device, this is about as much training as required. The start button and point the laser where you're inspecting. So we point it at the cap. That'll give you. So that basically gives you the ability to deploy this tool at scale. There are tens of millions of sources of methane out there in the energy infrastructure, and we have to make it a tool for every operator to carry in their truck, to pull it out and just say, hey, I scanned methane, there's nothing here, or I found the leak, I fixed it, I certified it post-fixing, and then report it. So we got pulled into maritime application. We actually are presenting to a consortium of shipping companies that are switching from diesel to LNG, and they want to inspect methane emissions on their ships as they sail. So any application.
Why the cap?
Oh, it's just easier. No, the methane is in the vial, but it's easier to explain people where to point. Okay. So otherwise, like, sometimes people struggle.
Hard to find methane with the naked eye.
That is actually the very important thing that you just mentioned. The United States EPA definition of optical gas imaging is visualizing methane emissions, otherwise not visible to the naked eye. So that's what we provide.
So tell me more about the company now in terms of how do you plan to manufacture these, or are you manufacturing them now? What scale, what break even? How many do you have to get in the market to start to turn that around? Some sense of that.
So the bill of material of the unit is 10 grand, and we manufacture it in an extremely low-cost manufacturing location called Brooklyn, New York. I kid you not. So our hardware genius works out of the new labs in Brooklyn Navy Yard. We have 35 units made, which allows us to go cash flow positive when we deploy 30. But we need to scale up to the next level where we are producing them in hundreds. Xplorobot received the authorization from Food and Drug Administration to import our devices into the United States so we can manufacture them in a third country. We would probably prefer to manufacture them in Singapore, but the components are commodity components that are coming from different suppliers around the world.
Oleg, I was wondering, you made the comment about some companies that say, I can't afford this or I can't afford that. They say, I'll take your solution. But it seems like the flip side might be true, which is companies that are really big, lots of resources, lots of capability, say, I want anyone who's going into the field to have one of those devices, and because anytime you're there, I want you to check, or I want you to be able to tell me if something's going on. Are you seeing that? Is that how to think about this?
Yeah, that's our vision. It's basically Xplorobot in every truck, because methane emission needs to be an ongoing activity. It's not like once a quarter somebody arrives and then finds and then we fix it. It's actually, we send pumpers to the pads every day. Pick it up, takes 3 minutes to scan a wellhead, 5 minutes scan separator, 12 minutes to scan a compressor. You're there already. Scan it, bring back the scanner, we download the data, we deal with it. So it's actually embedding it in the part of operations, our vision. And one of our clients, which is a global major, they said, we actually would like to have this on every platform because breaks and scheduled offshore are so frequent. The part didn't arrive, helicopter didn't fly, the fog, whatever. Bobby is sitting there doing nothing. Hey, Bobby, why don't you scan some methane? Zero incremental labor.
And can I just ask you for fun, when you fantasize about how cheap you could make that, like what is the cheapest possible you could make that device if everything really worked?
$3 grand.
$3 grand.
Yeah, which in oil and gas world is nothing. Our payback on hardware is 4 days. I kid you not. This is a hardware payback at the current price of manufactured in Brooklyn Navy Yard. So it's really tremendously hypocritical of Teledyne FLIR to keep pushing a $120,000 camera and refuse to put R&D towards a cheaper solution. They can do it. We proved it. We're a software company, and we put it together ourselves. So we hope to really make a turn in the methane emissions space by providing a tool for everyone to use.
Oleg, thank you so much for the pitch and the great Q&A session. That's our final pitch. I have several thank yous. First and foremost to the incredible founders. As you can see, there's a lot of innovation in the spirit of advancing the future of energy, and we really appreciate their efforts to put together the pitch and be here with the panel today. I want to thank Andy Lubershane and Walter Isaacson for an outstanding keynote. Really appreciate that. I want to thank the attendees, both in the online broadcast audience and here in the room. You guys have been amazing and brought a lot of buzz and energy to what we're doing. I want to thank our panelists, Jeff, Maynard, George, Paula, John. As you can tell, they did a lot of homework. They took their responsibilities seriously today and really opened up some great conversation with these founders on their tech, and hopefully that continues in some of the networking discussions. And importantly, I want to thank the team that put this event together. There's an incredible number of people that were not on stage today that have been working for several weeks to look after all the details and make sure that we had a great experience for you. And they work really hard, and we appreciate what they do. Finally, I want to call attention to our next event. It's going to be a part of a new Houston Climate and Energy Startup Week It's going to happen September 11th, 12th, and 13th in Houston. We've got several great partner organizations, including Rice Alliance and Greentown Labs. The Halliburton Labs Finalist Pitch Day will be on Friday, September the 13th, but we're really looking forward to really convening a great global audience of energy and climate tech investors and innovators, academics, to continue the discussion. So thank you so much. It's been great to have you. I'm going to hand it next to John Atkinson, the leader of Idea Village.